join our Mr. Johan is a member of Management Committee of NICE and Deputy Secretary General of International Coalition of Intelligent Manufacturing. Professor Xuanmei is from the School of Material Science and Engineering, Southeast University, and also serves as the Dean of Nanjing Green Additive Manufacturing Research Institute. Welcome to our session. I would also like to welcome our esteemed speakers and give you a brief information about them. Professor Xuanmei, welcome. Her research focuses on earthquake and climate change-induced chains of geological hazards, long-term landscape evolution, and disaster risk reduction. She has recently received Chinese Young Woman Scientist Award. Congratulations for your award, Professor. As chair, she co-founded the Global Partnership for Smart Informatics and Multi-Hazard Reduction, aiming to address global challenges created by increasing multi-hazard risk and climate change in a fast-changing world. Thank you for joining our session. Dr. Zhang Yan is a senior structural engineer architect, chartered member of ISE UK, has been engaged in construction projects, designing, consulting, and treatment of construction accidents of decades of years. Thanks for joining our session. Professor Hasan Mandal serves as the president of TÜBITAK between February 22 to 2018 to 2024. He has appointed as the rector of Istanbul Technical University, one of the biggest universities in Turkey. He also has been serving as the president of WAITRO and will be continue as a president until 2026. Thank you, Professor and the President. Professor Orhan Tatar, thanks for joining our session, and he served as Vice Rector, Dean Director of School of Physical Education and Sports and Funding Department, Head of Occupational Health and Safety at the universities. He has appointed as AFAD General Director of Earthquake and Risk Reduction in January 2023. He has been serving as the editor-in-chief of TÜBİTAK's Turkish Journal of Earth Scientists, and he had completed his doctoral studies at Kiel University and postdoctoral studies at the University of Liverpool. Thanks. Thank you, Professor Tatar. Professor Wang Gonghui is a distinguished professor at Kyoto University and the head of Research Center for Landslide Risk Cognition and Reduction. He is also guest professor at the Lanzhou University, ZHONG University, China University of Geosciences. He has been conducting research for, I think, more than 30 years on geophysics, hydrology, geomorphology. Thanks for joining our session. Johan Moyersoen. Johan is the founder and general manager of the Impact Licensing Initiative. Before this role, he was a serial entrepreneur focusing on social business and intermediary supporting shared value and social entrepreneurship in Europe. He has a long history in academic journey as anthropology, regional science, economic geography at esteemed institutions such as KU, Leuven, Ghent University, Cornell University, and Oxford University. And he has founded the network of European peace scientists. Bianca, thanks for joining our session. Bianca Hanskens is the grant coordinator of Belgian Red Cross from Flanders region. where she has spearheads partnerships and resource mobilization efforts. With 20 years of experience in development and humanitarian work, both in the field and at her headquarters, she has worked with international NGOs, multilateral organizations, and the Belgian government across Latin America, Africa, and South Asia. Thank you for joining our session. Yes, as we know, the intensity and the frequency of natural disasters have been increasing, with the global warming acting as a driving force behind many of these catastrophic events. The impact of climate change is profound, reaching across borders, economies, ecosystems, creating unprecedented challenge for communities worldwide. This session provides a unique platform for researchers, industry experts, and policymakers to join forces, discuss how we can build more resilient cities, communities. And this building resilience is not just about protecting our lives, our infrastructures, but it's about fortifying our societies to withstand, adapt to, and recover from these increasingly severe climate impacts. In our session, we will explore earthquakes, climate change, induced change of geological hazards, long-term landscape evolution, and disaster risk reduction, landslides under abnormal weather conditions, innovative technologies, strategies for disaster preparedness, importance of research funding for the sustainability, and the critical role of impact licensing in ensuring that communities have timely access to life-saving technologies. Together, let's uncover the ways in which collaboration, sustainable technology transfer, and community-based resilience can help shape our cities capable of thriving in the face of adversity. Our section is structured into two key breakout sessions. In the first part, we will highlight climate change-induced change of geological hazards, long-term landscape evolution, disaster risk reduction, cutting-edge research and technologies, and their relationship between climate change and disasters, and practice strategies for the research funding and community-based disaster management. And in the second part of our session, we will discuss the critical role of impact licensing in ensuring that communities have timely access to life-saving technologies. This session will delve into the strategic use of impact licensing to expedite access to critical technologies during emergency. And this session will conclude with the panel discussion at the end, during which we encourage you, our participants, collect your questions, and our esteemed speakers will provide their perspectives in an engaging Q&A session. Okay, I'm really excited to start this journey together and exploring how we can leverage technology to create more resilient world. Let's get started with our keynote speaker, Professor Van Xuanmei. Now the floor is yours. Thank you.
Okay, good morning, everyone, and thank you very much for the organizing committee to invite me to be here today. So my talk today going to about how new technology empowers geohazard risk reduction. So myself is let's say, is an engineering geologist. So in the past 16 years, actually after 2008 Wenchuan earthquake, I mainly work on earthquake-induced cascading hazards. And in recent years, I shifted a bit of my research focus to climate change-induced hazards as well, particularly in the Tibetan Plateau region. So to start, I would like to first to say some words about my institute. I'm from the State Key Laboratory for Geohazard Prevention and Geoenvironment Protection, based in Chengdu. I think some of you probably heard about Chengdu. It's in the southwest part of China, the hometown of giant panda, and the delicious food, also hot pot, is quite famous. My institute, as you can see here, is a big institute and the only national level laboratory in China focusing on geological hazards prevention and engineering geology. I'm now also the director of this laboratory. And our laboratory had quite a lot of experimental equipments. Actually, Professor Gonghui Wang has been collaborating with us for a long time, and we have the big centrifuge laboratory and a large shaking table test, which can conduct shaking table, earthquake-induced hazards and building structure experiments, and a lot of field equipments as well. So you are really welcome to visit our institute in the near future. So we are the only national level laboratory, so we are responsible for hazard assessment and prevention of large-scale geological hazards in all over China. And we are also focusing on interaction between human activity and geoenvironment and geohazards. And we do also assessment and protection of geoenvironment and geohazard monitoring and early warning. So part of my talk today will be focusing on the early warning part of the hazards. So I'm mainly going to talk about 3 key components today. The first is about earthquake-triggered landslide prediction. So a bit background, as we know that actually a substantial proportion of world's large cities in the region actually in the high seismic zones. Apart from the direct collapse of buildings during earthquake-induced cascading hazards is a main contributor to death tolls, in total death tolls. And China is one of the countries has highest earthquake hazard in the world. So through this video, I'd like to give you an impression like what would happen during a strong earthquake. This is a video from the Wenchuan earthquake. You can see during the earthquake, apart from building collapse, there are many landslides, some of them even dammed river forming large lakes. And after the earthquake, we are also facing debris flow problems if you have heavy rainfall in the same region. I often like to show these photos to people. This is actually what I call a real risk city in the world. You can see this photo is Beichuan. There is a pointer here. It's not, it's working. Okay, this is before the earthquake. You can see the Beichuan town, quite nice place to live. But unfortunately, the fault is actually passing through this town. So during the earthquake, it triggered many big landslides, really big landslides. Some you see this one like killed 1,600 people. This one killed 700 people. And 4 months after the earthquake, the region has a big debris flow and it almost buried the old Beichuan town. Fortunately, at that time, this town was completely abandoned because most people were killed during the earthquake. Otherwise, this debris flow will cause more damage. So based on some statistics, the Wenchuan earthquake-induced cascading hazards actually contribute to 1/3 of the total death toll. So that is a really serious problem. So after the Wenchuan earthquake, we were thinking one question to solve is whether we can create an earthquake-triggered landslide prediction model, because this is very important for the emergency response. Because often during the large earthquake, the communications is often disrupted and the roads were blocked. For example, after the Wenchuan earthquake in the Beichuan town, which I just showed you, this risk town, there was no communications with outside. So people don't know at that time what happened there. So that's why my team has been putting a lot of effort to try to create a model which can give very rapid prediction of coseismic landslides shortly after the earthquake, providing information to our government for the rescue. So what we did is we create a global earthquake-triggered landslide inventory, including 54 events in total, we have more than like 400,000 landslides in this database. And based on this huge database, we can analyze what are the controlling factors for coseismic landslides. Once we know these controlling factors, we can use the current AI models. A lot of AI, people are really using all different kind of algorithms. So with all this data, with algorithms, we are able to create AI-based, like data-driven model for predicting earthquake-induced landslides. I'll show you some examples. So we also built a platform for this. Now our model runs very fast. 1 minute after the earthquake, we can get the prediction of coseismic landslides in the region. And then we also create a global model, and both global model and regional model. We tried with many earthquakes, not only occurred in China, but globally. This is the example from the 2016 Kankura earthquake in New Zealand. So you can see our model, both the regional model and the global model, performs very well with an accuracy of more than 85. And this is a Haiti earthquake in 2021. You can see the model also did a great job. It actually has an accuracy of about 94% of the landslides we predicted actually fall into the zones we predicted. Actually, we also did the Turkey earthquake, but we did not put the results here. I sent the results to Toga at that time. Yeah. And I'll show you one of the examples. This is an earthquake with magnitude 6.8 occurred in the Luding region in my province. And 2 hours after the earthquake, we gave our government, the emergency center, this map. So this map basically shows the red zones are the zones which we predicted has high earthquake triggered landslide probability. And then later on, when we get the remote sensing imagery and with the field investigation, you can see in some zones, these black polygons are coseismic landslides, which are actually most fall into the regions we predicted as a high probability. So this is how the model works. And then, of course, after the earthquake, if you can immediately get the remote sensing imagery, now with the AI models like face recognition, we can also do very rapid like mapping of coseismic landslides. Of course, this will be more accurate than our model because the model is based on the data from past earthquake events, but the remote sensing imagery is real time. So again, I show the Luding earthquake example. So here, after the earthquake, our government signed quite a lot of drones in the region to quickly get the imagery to do a hazard assessment. So our model can do is basically we got the drone imagery, and then we can do the automatically mapping of coseismic landslides. Like here, all the yellow polygons are all landslides regions. And then we can also map the damaged buildings and destroyed roads. So this is, I would like to show this as well. So this is how So for example, in our platform, if you have an earthquake and then the model quickly run, and then give you the results of the spatial probability of coseismic landslides. And then can also do the mapping. I think the mapping part did not show, strange. Yeah, here, this part is on the mapping. So you select one region and the model automatically map all the coseismic landslides. And then we also have a global earthquake platform, which you can basically select any earthquake, and then it quickly show you how the coseismic probability of the earthquake quickly. So as I said, the model run very fast. Almost we call it a near real-time prediction model as an earthquake. So now I'm going to move to the prediction of cascading hazards. As I showed in the previous video, one of the big problems we have is some of these landslides may dam river and forming landslide dam lakes. So these lakes are particularly dangerous because it's a loose material formed normally. And once the dam breach, it will causing flooding to the downstream region. So our research is really focusing on how to predict the chain hazards. So we have a model to simulate during earthquake, which part of the slope will fill, and once it forms a landslide dam, how stable the dam is. So we do stability analysis and dam bridge flood simulation. So with these three components, we can run the whole scenario of the cascading hazards. Again, I'm going to show you one example formed by the 2008 Wenchuan earthquake called Tangjiashan Dam. It's actually upstream of the town I just showed you. You can see here it formed a big lake with 0.3 billion cubic meters of water in the lake. And unfortunately, 2 million people are living downstream at that time. So this is the big lake formed, and this is one of the second largest city in our province called Mianyang downstream. So if this dam breached catastrophically, it will affect a really huge population downstream. So our government quickly built a spillway to try to reduce the potential flooding risk. So at that time, what we did is we tried to simulate, based on different scenarios, what would be the flooding to the downstream. So this is how the model works. So we have this dam, and then we set up the dam bridge flood modeling. So basically, we can predict the flooding, like depth, velocity, and flooding area quickly. So because I don't have time to go into details, if you are interested, actually my PhD is on, back in 10 years ago, was on actually landslide dam cascading hazards. And recently we also have 2 papers on Earth Science Reviews, actually all on this landslide dam problems. And the last part I'd like to talk about, do I still have time? Okay, yeah, I'll quickly show this part. Last part is about landslide monitoring and early warning. So this is one of really the key problem, because everyone working on geological hazards try to solve 2 key questions. One is where they gonna happen, right? And the other one is when they are going to happen. So this early warning system actually solved the problem when this landslide is going to happen. So our laboratory put a really great effort in developing what we call a real-time landslide early warning system. The system is showing here. I will not go too much details here, but I would like to mention this. So in China, back to, I think, 20 to 30 years ago, people are always using threshold early warning system. For example, I put a displacement sensor on a slope, and then I measure the displacement, and then I give a threshold, let's say 20 or 30 millimeters per day. And then if it's above that threshold, it will send alarms. But definitely this will not work, because every landslides, like human being, they are different. Everyone has its own story, so we can't find really a single threshold for all landslides. So that's why our laboratory did quite a lot of research, and then based on the geological conditions of these landslides, we find they actually follow different patterns. And then we install a lot of sensors in the field to monitor the landslides. And what we found in common, especially for this type of landslides, before sliding, it will have a kind of acceleration stage. So once a landslide enters into the acceleration stage, the landslide will occur sometime quite soon. So based on this, and also together with the current AI models, we actually built a system for many provinces in China, like Guizhou province, Gansu province, Sichuan province. And in total now, we have already early warned more than 400 geological hazards precisely. I'll also give you one example. This is a landslide occurred in 2019 in Guizhou. This landslide occurred in the early morning, 6 a.m., and our system gave the alarm. So we were wake up because we have the app in our phone, and then mentioning this landslide is very dangerous. And then we phoned the mayor of this city, asked them to evacuate people below this landslide. And then about 1 hour after we sent the alarm, the landslide happened. So fortunately, the local government took a very rapid emergency response, so no people were injured or killed by this event. So IAEG, the International Association for Engineering, Geology, and the Environment, put this the news on their website. And then I just presented the early warning for landslides. For debris flow, it's a bit different. This is the situation after the Wenchuan earthquake. As I mentioned, we are really facing serious debris flow problem. As you can see here, almost every gully had a debris flow occurred at that time. For example, this one, like also run into one river and partially dammed the river and causing the flooding of our newly reconstructed town after the earthquake. So after the Wenchuan earthquake, we also built a big database on debris flows, including more than 500 post-earthquake debris flow and their rainfall condition. So based on this, we are able to find a threshold changing for rainfall threshold changing after the earthquake. So you can see these are basically the threshold before the earthquake is quite high actually. But we could not use this to predict the post-earthquake ones. As you can see here, if we use this pre-earthquake level to predict post ones, you can only predict one event. And then what we find is after the earthquake, the threshold actually decreased a lot compared to pre-earthquake level, and then it's increasing over time. So this is what we did after the Wenchuan earthquake for debris flow, which are mainly based on the rainfall intensity and the duration and the correlation of debris flow events. And then in recent years, we are moving our focus to the Tibetan Plateau region. That's definitely because of the climate change. As you can see here, due to climate change in the Tibetan Plateau region, we have several major types of hazards, glacier collapse, ice rock avalanche, and GLOFs, glacier lake outburst floods, and glacier debris flows. So this is one event occurred in 2000, which dammed the river and formed a big lake. And this lake breached 1 month after it was formed and causing flooding even rushed to India. And this is another event, quite recent event in 2021 in the Himalaya Indian part. You can see it's a rock avalanche converted into a rock as debris flow and end up as a flooding, destroyed 2 hydropower stations downstream and killed more than 200 people. So this is a serious problem in the region due to climate change. But it's a hard, really hard thing to do early warning in this place, in these regions, because basically these regions are on the top of the mountain with an altitude almost like 5,000, 6,000 meters, not accessible. So we could not put any kind of in-field sensors on this type of slopes. So after the Chamoli event, we tried to backtrack the remote sensing imagery, and what we found quite interestingly is before the event, actually between 2015 and 2017, there is definitely one event happened before. And then this 2021 event, before it happened, actually it has serious deformation process. Like these are the cracks before 2 days before the event. This is the after the event imagery. So you can see this actually the field exactly follow the cracks developed in the slope before the landslide. So again, if we track the multi-temporal remote sensing imagery, you will see 2 months before the landslide actually occurred, it already entered into an acceleration stage. So if somebody would know this region and would check the historical remote sensing imagery, then definitely this landslide can be early warned. But unfortunately, the region is so big, so you don't know which region we should focus. And this is in our Tibetan Plateau region. One of the catchment is very active recently. You can see there's a number of events happened. Even there were 6 events occurred since last year and dammed the river frequently. And there are a huge amount of sediments in the catchment. So we are working a lot in this catchment now, trying to come up with some early warning system. I will skip this part. There was one event last year in September, and we now have installed the early warning system there, but not really in the initiation area of the catchment. What we did, we found it quite interesting, is through seismic stations. So seismic station not only record earthquake, can also record big landslides and debris flows. For example, this one is actually from last year's event. During the main rock avalanche, it generated these signals, and it also recorded the whole damming process. And after the event, before the event, you can see the dust is actually created by this signal. So there was a big rock avalanche occurred upstream, and then later on, you will see the debris flow come out from this catchment, created these signals. And after that event, after this debris flow event, there were two small rock avalanche events somewhere on the upper part of the catchment generated dust here. So you can see it actually correlated with the seismic signal very well. So now we are trying to use the seismic station to come up with some early warning solutions, because in this region it's not possible to directly put any displacement sensors on the initiation area. So this is our ideal system, which will work based on the mainly on the seismic station and other sensors. We hope in the near future we can come up with some new early warning models for the Tibetan Plateau region. So yeah, we also have quite some papers on the Tibetan Plateau region work. So if you are interested, I think you can find many. Also this year, we have several papers on the Tibetan Plateau cascading hazards. So with that, I would like to, I think I already take more time than scheduled. Thank you very much for your attention. And also this is really quite a lot of field work involved with my whole team. I would also like to thank my team and all the collaborators. Thank you. So the question will be live in the afternoon, right? Sorry, QA session.
Okay. Thanks very much to Professor Xuanmei for her insightful keynote and for setting the stage for today's discussion on the convergence of resilient cities. Thanks again once more for her very inspiring talk on why and when answering this question, importance of academic research, how we can tackle with this issue with the universities. Thank you. Now go to industry and invite our next speaker, Professor ZHONG Yang from South East University Louis Vibration Control Research Center. Now the floor is yours. Thank you.
Thanks for meeting host. Good morning, everyone. Today, my presentation is about the seismic isolation and energy dissipation technologies in China. And I will call the site as an abbreviation of seismic isolation and energy dissipation. And the site building means a building which applies the site technologies. The background. Everyone knows that among the various nature disasters, the earthquake is completely beyond our control. We cannot predict when or where it would happen or how strong it could be. After the devastating Tangshan and Wenchuan earthquakes, the Chinese government officials and engineers in construction fields, they are eager to develop a new strategy to protect their buildings and peoples in case of earthquake. Now, they are approaching the goal. In July 2021, the Chinese government issued the regulations on anti-seismic management of construction projects, which is the first one in this field since the PRC was founded. The regulations mandates the site technologies on 8 categories of buildings, including schools, kindergartens, hospitals, emergency shelters, etc., especially in the areas with higher earthquake risk. The regulations is widely discussed and considered as a key step to build a resilient city or resilient society in the future of China. Primarily learning from Japan, China began to research on the site since the last century. After 30 years' effort, nowadays China already has 25,000 buildings with site. More than half of them are in Yunnan province, where I came from. Now, the Chinese government determined to push on the technologies around the country, but on certain aspects, the site technology is quite different with the traditional earthquake-resistant technology, and most people have not fully understood this difference. Thus, the implementation of regulations could be both rewarding and challenging. Opportunities. Obviously, the issue of regulations is a great chance for site industry. It brings a huge market. For instance, there are more than 300,000 kindergartens and 160,000 primary schools in China, which means a massive number of buildings are subject to apply the site in seismic reinforcement or rebuild in the future. Certainly, there are many new build projects too. And the governments in China also encourages application of site in other public projects, such as airports, railway station, sports venue, shopping center, etc. We believe with the growth of the market, the technologies will benefit from the active investment, the healthy competition, and the continuous gathering of intelligence in this field. Challenges. It's not an easy topic, but I want to talk more about it. Firstly, it's challenging for Chinese government to administrate the site market effectively. It's so huge, so important, and growing so fast. It's widely believed that the government has the obligation to ensure that technologies are enforceable. Secondly, there are serious cognitive barriers about site. For most people, the site is thought to be one certain product. Once the magic product is fixed in place, the building gets seismic safety forever. Unfortunately, the people often ignore the fact that the magic power of a site is quite conditional. The site is not only a product, but also a system. The site buildings can be seen as a combination of high-grade manufacturing and the traditional construction industry. In a sense, the site buildings are machines and not a simple one. If the traditional earthquake-resistant buildings were compared to staircase, the site buildings would be elevators. Those elevators bring us convenience and comfort when going up and down. It's much more complicated to maintain the elevators than the staircase. So far, not all technical issues about site have been resolved or even been recognized. Some existing site buildings are not in good conditions, but there is no building record system like that of cars. It's very difficult and expensive to replace the defective isolation and damping products, as well as to amend the construction floors exist. Generally, the longer the problem exists, the more people will lose the motivation to address it. They may incline to forget it, but the earthquake would not. To ensure the site building function well, the first concern, of course, is the quality of the products. There are so many kinds of products about site in China. Some of them are very newly developed. We need to be very cautious, even if they have the perfect, excellent performance in the laboratory. The laboratory conditions differ from those in the practical engineering. The strictly test should be insisted before making the choice. Furthermore, the key point is to establish effective communication. There is a big misunderstanding even in the professional community that the site is the only matter for structural engineer and has nothing to do with others. In my opinion, that's the root of almost all problems. In fact, we need everyone, the architect, the construction engineers, the government officials, and the property owner or users to work as a team, to play the dual role for safety and resilience for site buildings. After visiting hundreds of site buildings, we have found it's usual that a property owner or the building users, they do not know they live in a site buildings, let alone know how to maintain it. For so, in 2015, the engineers in Yunnan, they have compiled a local technical manual, instruction for the site building information notation, which stimulates in detail that necessary information should be given to the owner and the users of the site buildings. It's a good beginning, but just a beginning. When you buy a car, you got an owner manual and the service book, which can help you to drive, to enjoy, and take care of the car. And we need a building operation instruction too, especially for the site buildings. It should be part of the management and the building's ID and updating in time, just like the healthy records of people. As the need of seismic safety is growing up, there are more and more old buildings in China are subject to seismic upgrade. We have many successful cases of applying site in reinforcement and some lessons too. Currently, in Yunnan province, there is a 12-story retrofitting project just finished, applying the base isolation technologies. You are very welcome to pay a visit. I can be the guide. On the other hand, we must bear in mind that the site buildings are very sensitive to changes. The architecture and the circumstance renovation ignore the side factor could damage it, or even cause the loss of its function. That's dangerous if earthquake comes. The site buildings are technically progressive, but at the same time, they are fragile. It's difficult to destroy or damage your staircase. You need a big hammer and a lot of strength, but it's quite easy to stop an elevator with just a layers clipper to cut a wire. Only if we take good care of the site system in the building, it in return can protect us when earthquake happens. The last part, expectations. The earthquake do not stop at the borders between countries, and the efforts of anti-seismic too. In this year, I attended the CIS annual conference on earthquake resistance in Almaty, Kazakhstan. The officials and engineers coming from Central Asia, they have shown great interest inside, partly because the earthquake happened in Turkey 2023. Through academic, technical, and project cooperation, we'd like to offer our help in the application of site in Kazakhstan and Central Asia. As I know, the Jiangsu Lihui company, who specialized in this field, has set up an office in Almaty and a product testing center is also underway. Now, China has the largest number of site buildings in the world, more than half of total, and the number is continuing to grow. I believe that everyone around the world who care about the site buildings, who care about the resilient buildings in society, they could benefit from Chinese experiences and lessons too. The site technology is good, but it's not easy. Let us work together. Remember, earthquake could happen anytime, and we must run faster than the earthquake. Thank you.
Thank you, Professor Zhang Jia, for this nice talk and reminding us the importance of regulations, importance of co-working, collaborating together with academia, architects, engineers, all together. Thank you, and let's move on to our next speaker, who is the president of WAITRO and the rector of Istanbul Technical University, Professor Hasan Mandal, who has established several funding programs during his presidency to TÜBITAK, and he will give a talk on the importance of these funding opportunities. Thank you, Professor.
So good morning to everybody. So it's a great pleasure for me to be also attending this session. I mean, this was decided in last June. I mean, when we are preparing the WAITRO summit, we have been discussing the different type of topics and how the WAITRO can be a kind of an organization, can bring all the right stakeholders, because this is a kind of an issue. We are talking about the sustainability and a global innovation family, so which I think this is one of the point of the disasters resilient future. I think is one of the issue, and I am sure that this will not be the end and will be take over for the future summits of our WAITRO community. So in here, so I am just going to be, I mean, maybe an overview and also sharing of course, the experience within our country of Turkey. So I mean, I am giving a kind of an example from the WAITRO perspective, and also in terms of the case study, maybe from our local, how we are responding to especially after the last earthquake, just has been mentioned in February 2023. I mean, I also showed this one yesterday in my talk of the opening remarks, saying that, I mean, when we are talking about maybe in terms of an academic, so go directly to the topic of the subject in detail, but also looking for in a policy level, because if we don't create the right awareness in the society, then still it could be left as a kind of an academic study. So, I mean, when we are looking for more general, I mean, general in a sense of how these extreme weather events, I mean, including the I mean, earthquake and the other type of disasters, which we can call it, how they will affect our life. Life means in terms of the food security, water security, energy security, involuntary migration, which we have been unfortunately faced last year. I mean, from 11 countries of the, so it's about nearly 10 million people moved one place to another in a very short period of time. So I mean, so this, and this brings the social problems, economical problems, and also the technology is supposed to be bring a kind of a solution, but also coming with the risks. So it is so when we are talking about the disaster resilient future, so in fact we are talking about a kind of a complex problem. So in here again has been just seeing that, I mean, in the right-hand corner of this diagram, showing the risks for the short and the medium, which we can call it 10 years period of time. So it has been much more addressed in here. So when we see them, they are extreme environmental events, so the earthquake, the flood, fire, heat waves, storms, cold. So these are what we have been facing, and they are interconnected to each other in terms of the type of other challenges in terms of economically, socially, geopolitically, and also technologically. And I think one of the good sign of it, at least that, we have been working the people or the researchers or the scientists that is in a one sense that, it's first time, it is not an easy, but all the stakeholders, so which means that the civil societies, international organizations, academy, government and private sector, they are more or less agree in terms of the priorities, and they are putting all top of the agenda, so which means that this is a kind of a policy level. I think it's quite important. All the stakeholders, putting the same kind of challenges in the same order, more or less in the same order. And in terms of also the solutions or expectations, in one side is the highest one is in here. Maybe you can see that, so the global treaties and agreements. And the second one, which is, I think, is very critical for us, is an important for is research and development. So so this is I think is the highest expectation, at least in global sense. I am sure that responsive to the certain countries, always the case, but in terms of the global sense, that research and development is becoming is very critical and the number one issue in terms of facing this type of challenges. And also when we are talking about, the disasters, of course, we have been putting much more efforts on earthquake. This is much more severe in terms of affecting the more people. But when we are talking about the disasters, natural disaster, and maybe in the past that, the earthquake are the main disasters, but most recently, because of the climate change, that, different type of disasters on the basis of the extreme weather events, so which we have been facing, at least again in compared to our country. So you can see in here, so in terms of, you will hear the next speaker also from our country, and he's coming from the organization called the AFAD. So he will give the more details in terms of how we are managing, but in terms of the description that so geophysical, hydrological, meteorological, climatological, biological, and extra terrestrial type of an issues that when we have been putting in under the different type of categories in terms of the natural disasters. And this is for year 2023. I think this is unfortunately the highest number of disasters. And so number one in Indonesia, and the number second is unfortunately my country is of Turkey. So we have been faced. So the many people, you can see in here. So nearly 20 million people have been affected because of the earthquake which we have been faced. So, and this has been repeating in different type of means, maybe not as an earthquake by itself, but other types of the disasters. Of course, so when we are always talking about how we can manage the disasters, so not only just after, as our country, that we have been well experienced, especially after natural disasters, after the earthquake. But I think more issue, and we have been discussing in this session that how we can, especially before the natural disasters, so what can we do and what we can learn, and because the R&D is becoming much more important before natural disasters case. So in terms of our policy level of our, as an experience in our country, so this is our 50-year plan, and is the first time again putting the highest emphasis on so the resilient, so reducing the disaster risks and damages, and integrated disaster management and resilience and cooperation is the first time is becoming that is one of the 5 pillars of our country. So I mean, in the past, that I mean, is only maybe a kind of an item of the given to the certain organizations, but now it is given to all the organizations, especially the earthquake, which we have been faced last year. So it's every policy or every organization has been responsible in this respect. And from the funding level, so this is I mean, I have been served for 7 years at our National Science Foundation of TÜBITAK, and is a member of the WAITRO as well. During, I mean, this is a funding priorities in terms of the year 2024 and 2025. And the second pillar is the research, development, and innovation for disaster management, so before, during, and after, and also covering the all type of earthquakes, so disasters. So, I mean, of course, more on the earthquake, but also floods, the landslides we have been just heard, and fire, so, and also the others. So these are becoming kind of an agenda. So, I mean, any kind of, we have been showing as an interest. I mean, we means as a Turkey that, I mean, there's a joint cause and different type of potentials are applicable if we would like to work bilaterally or multilaterally. And so there's again some cases, unfortunate cases in, for example, in year 2021. So this is a kind of, I think, in the history of the, I mean, more recent history at least. So, I mean, including the, I mean, so-called developed countries. So there are many fires, which has affected 39 countries. I think there's a kind of a video. I don't know if it's available or not, but not the case, no problem. Again, so this is a kind of a study has been done in just afterwards, how it is affecting our all lands after these fires. But what we have been learned is, I think, one of the, I think, an issue that critical that, so to how we are responsive. So this is after the earthquake in 6th of February in 2023. So nearly, I mean, more than how many is 60 or 1,000 people passed away. So 53. Okay, so I mean the exact numbers. So 53,000, I mean, people are citizens has been passed away. So it is the highest number in our history. So, but one of the things as a researcher, how we have been responded. So I think this is, I am sure that, I mean, every country had a different type of an experience, but at least that this is one of the positive sign. It's the first time which I can say that after the earthquake, within 24 hours, after the earthquake, within 24 hours, we fund 124 projects in one, I mean, just because I think one of the important issue, just go to on-site and work. So it's normally the funding means, I mean, you need to apply and wait for certain periods and the panels and things, and at least 3, I mean, minimum in our conditions to 3 months to 6 months. But these all projects of nearly 124 projects from the 61 institutions and 600 researchers are on the field in the next days. And not only on research coming from the earthquake by itself, but also coming from the social science and humanities and the different type of subjects on the in terms of the engineering, the civil engineers. So they're all in the field, and all the data has been collected very fresh, and also I think giving a kind of a positive sign that all the researchers we are always talking about how can we work and how can we collaborate and how can we co-create. I think this is one of the, maybe we can say that, I mean, a kind of a use case, because this is a program now is running every after disasters. Although we are not look, I mean, we are not hoping that, I mean, it should be a disaster, but at least there's a special program developed after this earthquake. And another one, maybe as a kind of a use case, we formed a platform within our country. So all the relevant stakeholders, so I mean, we have been prepared, preparing the, I mean, our so-called faults. Yeah, paleoseismological study. I am a material scientist, so not in the field. So I mean, so there's always each scientist or each researcher, each group doing their own. But now is the first time again making the right study on the paleoseismological study of all the faults in our country. So bringing I mean, the relevant universities, so the researchers, the institutions, they are working together for I mean, at least for the next 2 years. So again, which we think that, I mean, is a kind of a platform, and also including the state agencies, so which means that, I mean, they are making their plan for the, I mean, housing and everything for the future. So this is a kind of which we can say is a kind of a gain. And a special example to do my own university now currently working on the Istanbul Technical University. We have a special institute on the Earthquake Engineering and the Disaster Management Institute. And within this, also you can see that in terms of the publication, journal publications, there's a kind of at least an outcome, maybe not the right impact, but it's showing that a big interest is going on in different perspectives. And the final one, of course, the collaboration is one of the important issue, and especially, I mean, we are working with many European institutions and organizations in many different type of perspectives in terms of the different type of disasters. But as from the WAITRO perspective, I think we should be able to bring in the same sense that different, I mean, organizations are the members of the WAITRO, so nearly 170. So we should form this kind of a collaboration or co-creation platform on special to do, because I think we will face for the future so different type of disasters, and these will be affect the sustainability of in global family. So thank you very much.
Thanks very much to President and the Rector, Professor Hasan Mandal, for his insightful talk. Also, many thanks for being the driving force behind the Turkish research ecosystem on building resilient cities. Let's move on to our next talk, to Professor Orhan Tatar. Now the floor is yours, and his talk will be delve into the disasters in Turkey and critical role of the community-based management. Thank you, Professor.
Thank you very much. It's very nice to be here and to speak in front of such a distinguished and also very young people. This is a very important situation for me. Well, I'm a professor in geology, and I was working for a university for the last 37 years, and I was appointed to the AFAD. AFAD is a Disaster and Emergency Management Authority of Turkey, just 2 weeks before the earthquakes. So I was so unlucky, but I had the most experience in my life after the last 2 years after the earthquake. So today I will mainly concentrate on what we have done after the earthquakes and how we did respond to these earthquakes and what we are doing so far as a recovery stages in the earthquake region. And as you know, we had 2 major earthquakes in February 6, 2023, last year, mainly in the southeastern part of Turkey, directly affecting 11 provinces, and also indirectly 18 provinces were affected by these earthquakes. And as a result of these earthquakes, you see here a video. the economical impact of these earthquakes was around 105 billion US dollars. This is quite a large number of economical loss caused by these earthquakes. So I'll just pass through this video fastly. So on the same day, this is a really a unique example in the world that we faced a large, two devastating earthquakes on the same day with 9 hours apart from each other. This is quite a large number of earthquakes. And as a result of these earthquakes, at least 570 kilometers of surface breaks was formed in the region. And since the 1st of January 2023, we had almost 94,000 earthquakes. Most of them were the aftershocks of these two major earthquakes in the area. Normally we record 25,000 earthquakes in a year in Turkey, but this year we've recorded at least 94,000 earthquakes in the region. If we compare the size and the population of the earthquake area, this is quite interesting. Well, the area directly affected by the earthquake is larger than many European countries. Well, if you have a look at this, slide, it is 3 times larger than many European countries: Denmark, Switzerland, Holland, and also the size of Bulgaria, United Kingdom, South Korea, and some other countries. And also, the population directly affected is about 1.5 times larger than the population of this city, Nanjing. And another interesting data is that at least the 100 United Nations member countries are about, the land area of these 100 United Nations member countries is lesser than 120,000 square kilometers of that area. So this is an important data for the earthquakes. As I said, we had $104 billion economical loss after these earthquakes, and we responded to these earthquakes with a people of 35,000 search and rescue staffs. This is a quite high number. If you see, we have about 2,300 AFAD search and rescue teams, but we also received at least 11,500 search and rescue staffs from the 90 countries. This is very important. So at this stage, I would like to take this opportunity and give my heartfelt thanks to all nations, to China, to many countries, sent their search and rescue teams to these earthquakes. But that wasn't enough. This is an important issue, because we had at least 39,000 buildings were completely collapsed. This is a shame, really, but 39,000 buildings were completely collapsed after these earthquakes. So we responded to these earthquakes with about 35,000 search and rescue teams after the earthquakes, but that wasn't enough, even though it was the largest search and rescue teams responded to large earthquakes in the world history. So these are the search and rescue teams from different countries. And as Professor Mandal said, this is the exact number of the loss of life: 53,707 people, unfortunately, we lost after these earthquakes. Well, we had one of the largest evacuations after the earthquakes, and in the first week of the earthquakes, we evacuated almost 3.5 million people from the earthquake area. This is a quite important operation. And additionally, in the meantime, we've sent all these, staffs from the different parts of the region into the earthquake area for providing all these services in the region. And before and after the general elections in May 2023, about 1 million people were traveled into the region, and their expenses were covered by AFAD. And also, we have a general university entrance examination in our country. And in June 2023, about 120,000 students were traveled into the region because we evacuated them from the earthquake region into other parts of the country. But in the university examinations, they just came back to the region and got their examinations in the area. So in the meantime, we provided temporary sheltering for the earthquake victims, earthquake survivors, and also we have provided some dormitories, guest houses, and pensions in different parts of the country, and almost 1.2 million people were accommodated in these kind of accommodations in different parts of the country. And in these operations, we used many vehicles. Can you imagine 20,000 vehicles, excavators, and so many helicopters, aircrafts were used for this evacuation. And almost 200,000 aid trucks, trailer trucks, were sent to the region to transport, relief supplies. And only Turkish Airlines, this is an important number, Turkish Airlines alone has conducted at least 14,500 flights and transported more than 2 million people from the region with no cost. This is important. So 14,500 flights conducted by Turkish Airlines, so thanks to them. And in the meantime, in the first week of the earthquakes, we started to provide temporary sheltering for the earthquake survivors, and 1 million tents sent to the earthquake region, and we've set up at least 645,000 tents in 350 tent cities, and accommodating about 2.5 million people in tents. But at the moment, we have no tents. In the first week of the earthquakes, we also started to construct container cities. We got so many containers and tents from China. We purchased so many containers and tents from China. So thanks to these, private companies, thanks to Chinese governments for providing us these, tents and containers in a very short time. This is very important. And at that time of the year, the total number of the tents throughout the world was about 450,000. So in a short time, we provided 1 million tents to the region. This is important. So in the container cities, we had 221,000 containers constructed in the region. So can you imagine, we transport 2 containers on 1 trailer trucks that needed at least 110,000 trailer trucks to send these containers into the region. That means a queue between, northwestern part of Turkey and to southeastern part of Turkey. When you, line up end to end these, containers or trailer trucks, that means 2,400 kilometers in length. So in the meantime, of course, the nutrition and daily food service was so important. We provided 4 million meals for people per day, and also produced 12 million breads daily, and a total of 20 million of food parcels have been distributed to the people by AFAD and also some other non-governmental organizations. This is an important slide. Okay, we have constructed so many container cities, but in villages, we also separately provided foldable containers that came from China. This is a foldable container, but we have to find a new technology for this kind of permanent houses, because this is okay, this is very nice, but the problem is to construct this. Okay, you carry at least 10 foldable containers in 1 trailer trucks, but you need to have a crane to construct these in the rural areas. So that's a problem. So we need to think about a new type of technology to have permanent houses in this kind of regions. We had a a very extensive structural damage throughout the region, unfortunately, and in 18 cities, directly or indirectly affected by the earthquakes, we have carried out a damage assessment work, and we've searched at least 2.3 million buildings. 2.3 million buildings, and as a result of these damage assessment works, at least 306,000 of buildings were severely damaged. This is quite a large number of damage in the region. We had also some damages in our historical and cultural assets, you see here. And after these, damage assessment works, we started to have the right ownership studies in the region. And as a result of these right ownership studies, we have almost 445,000 right ownership. That means we need to provide them for permanent houses for these people because their houses were severely damaged or fully collapsed. And so far, this is an important number, so far, in 22 months after the earthquakes, we have constructed 130,000 permanent houses throughout the region in 11 provinces and distributed to these right ownerships in the region. And about over 300,000 are being constructed at the moment. And by the end of this year, this number will be about 200,000 permanent houses, and by the first half of 2026, we will complete all the permanent houses in the region, which will be 450,000 permanent houses will be constructed by the government and will be distributed to the right ownership in the region. And these are the pictures from the permanent houses completed throughout the region and new cities rising up in the region. This is quite important. And in 11 cities, we have already completed 130,000 permanent houses, and this number will be 200,000 by the end of this year. And here is some more pictures. Okay, so these operations, the actions taken so far after the February 6th earthquakes are undoubtedly the largest post-disaster recovery operation in the world. But I hope it will be the last for us because we don't have any more devastating earthquakes, or at least in the near future, and we should try to create a resilience, more resilient cities and populations, communications in our country. This is important. So these are the pictures from the earthquake area, new cities, new permanent houses, and we had also some new houses for the villages. Different types of constructions are going on at the moment throughout the region. And this is the overview of damage assessment after the February 6th earthquake. So if you concentrate on these diagrams, most of the damage on buildings was on the buildings constructed before 2000. This is very clear. And on the right-hand side, that shows the number of the buildings constructed according to the latest earthquake building code was okay. This is important. Almost 150,000 of the buildings were constructed according to new, latest building earthquake code. And we had only 686 buildings were fully collapsed. That may be caused because of the local soil conditions or the proximity to active faults or some other liquefaction effects and so on. So even though we are nowadays trying to update our building earthquake code and also trying to make our own model, the Turkish model, the Türkiye model for earthquake resilient cities, that should be more rigid, better system and more detailed. And we are trying to make the shear walls are mandatory. Shear walls are quite important, and we are nowadays trying to make these shear walls mandatory for the new constructions in our country. Professor Mandal indicated about this. This is a very important point also. Even we had a very large earthquakes in our country. We also decided to establish an earthquake clearinghouse just 1 week after the earthquakes, and Dr. Duygu Celik had also a great contribution to this earthquake clearinghouse, thanks to them. And we received so many people from different countries of the world, and they came to Turkey and first came to AFAD, and we accredited them and sent to the field, and also provided some logistical supports in the field. And at the end of their studies, they downloaded their findings into our database, and we collected at least 1 terabyte large data now in our databases. This is a quite important operation we've done just after the earthquakes. So this is our National Earthquake Strategy and Action Plan. I will not go into detail, but we had so many projects carried out as part of this National Earthquake and Strategy Plan. And we also had some important outcomes from this plan: Turkish active fault map, national earthquake observation networks, earthquake hazard map, and many, many others. So this is another important that arose from our collaboration between AFAD and TÜBITAK, the Turkish Scientific and Technological Research Council. And I would like to extend my heartfelt thanks to Professor Mandal. He is the former president of TÜBITAK. After the earthquakes, we initiated a joint call. We learned so many lessons from the earthquakes, and we had some priority areas after the earthquakes. You see these priority areas here in 4 main priority areas we had after the earthquakes. And we had a joint call on the 1st of April in 2024, and we had almost 230 project proposals, and 51 of these project proposals now were funded. This is important. The National Earthquake Research Program is run by AFAD, but this year, first time, we had a collaboration with TÜBITAK, and we funded 51 projects. But in the last 10 years, because it started in 2011, in the last 10 years, we had 65 project proposals were funded. But only this year, we funded 51 project proposals as part of this collaboration. So thanks to TÜBITAK again. This is our active fault map. As you see, we are lucky or unlucky, I don't know, but we have the highest or largest number of active faults in our countries throughout the world. Well, with approximately 500 active faults, the total length of these faults is around 15,000 kilometers in length, and comparable to the length of China, almost 3 times from east to west. From east to west, well, 5,000 kilometers from east to west, so 15 kilometers in length, we have active faults. And some of these active faults extend beyond the country's borders into neighboring countries. So that means the question is, where is next? Because the February 6th earthquakes was formed on these East Anatolian fault in our country, but the East Anatolian fault goes down to the south and joining with the Dead Sea faults towards the Dead Sea region in the south. So we have to collaborate, we have to also initiate a joint collaborations with these countries in the region to also mitigate the earthquake hazards. This is a very important issue that we should concentrate on. So this is the slides Professor Mandal mentioned about this. We have initiated a very important research platform for determining the paleoseismological characteristics of active faults in our country. And we have now a largest paleoseismology project in the world. This is quite important. at least 132 active faults, specially located around the earthquake area, because they were affected by these two major earthquakes, and also nowadays have the highest seismic risk in the region. So we started a paleoseismologic project on 132 active faults, working at least 100 researchers, 300 scholars, and also participating at least 24 universities and research institutions. So we are looking forward to having these, the results of these important projects in 2 years. We have earthquake information system. I'll not go detail into it, but we have our indigenous softwares in our country and trying to transfer these softwares and technologies into other countries. And we have also earthquake loss and damage estimation system that was quite useful after the February 6th earthquakes. This is an automatically generated report on the earthquake's size and impact from the AFAD RAD system, and capable of making automatic and manual solutions after a real earthquake, and can give estimated damage and loss of calculations after a real earthquake. We continue to install our alarm systems throughout the country, and this is the global seismic hazard regions. This is the final slides. I would like to indicate that you see we are on the same belt. Turkey, China, and many other countries are on the same seismic belt, and we must collaborate on the reducing of the seismic hazards, seismic risk throughout the region. This is a quite important issue. And the next slide will show you the annual global loss of life caused by the earthquakes. And as you see from the slides, the loss of life throughout the region are concentrating mainly in our countries, in Turkey, in China, in also southern part of the Tibetan plateau. So we need to have a really strong collaboration on this field. As a tectonically active two countries with very similar features, China and Turkey, collaborating more closely in this area and sharing their experiences with all countries worldwide would greatly contribute to reducing disaster hazards and creating disaster resilient cities and communities. And final words, what do we need and how to focus on? What we have learned after these earthquakes and on which fields we should really concentrate. And this is the summary of this question. Innovative and durable construction and digital technologies, search and rescue, and resilient communication. This is quite important. Health issues and also post-disaster waste management. Post-disaster waste management is also important issue. After these earthquakes, at least 30 million cubic meters debris removed from the earthquake region, because we had at least 300,000 severely damaged buildings. They need to be demolished after the earthquakes and also remove their debris into another region. So that's an important issue. Many things to talk, but that's the end of my talk, and thank you very much again for inviting me to this very important meeting. Okay, thank you very much.
Thanks very much to Professor Orhan Tatar to presenting us devastating effects of the earthquake in Turkey and the need for new technologies and innovation. We really need it. And he also highlighted the importance. He emphasized that, yes, we are on the same boat and we have to tackle this problem together. We have to collaborate and co-create to tackle with this issue. Just before the coffee break, I would like to invite our last speaker of this session, Professor Gonghui from Kyoto University, Japan. Now the floor is yours. Thank you.
Thank you very much. I'm very happy to be here, and thank you, Orhan, and share lots of details in the earthquake hit area. This reminded me the since last year I fight the landslide was Toga from ITU for 2 weeks. So yeah, thank you again, and so also thank you for your invitation and to share. Let me share our house talk on this kind of the impact of climate change on natural disasters. Actually, I was from Kyoto University. Our institute is Disaster Prevention Research Institute. The main issue of our research institute is on natural hazard. Yeah. So after getting this invitation, so I think perhaps I share some recent result from our institute. Yeah. So in my talk, I would like to briefly introduce the climate change, the geohazard, landslide, floods, typhoon, wave height, and storm surges. And finally, I want to summary my talk. And so here's the climate change. So perhaps I don't need to say, everyone knows that. Yeah. So as you know, so from our data, we can know the global temperature have reached about 1.2 degrees within the last 100 years. This is a global statistic data. And so here and in Japan, actually, we have more serious problem. So here, I think it's laser. So this is for 100 centuries, the data from the global data. But from Japan, the data is about 1.3 for the 1 century. So that means in Japan, the increased tendency is more serious than the globally. And also in Japan, you can say here is the CO2. It's Japanese. Here is the CO2 concentration. So you can say they got the data from Several Island. So okay, obviously it's very clear. So it's increasing sharply. Okay, and here is however, the water, okay, the annual precipitation. You can say it got the data from sometimes it has increased. This is the standard value, and this is variation. So from the variation, so from here you can say this increase and then decrease and increase. So from the data, actually, you cannot say this kind of increasing data. Yeah, sometimes it's lower. And however, if you say the precipitation, you can know. And the annual precipitation is not so sharply increased, but from this kind of stronger rainfall, you can say, is for example, the daily precipitation larger than 100 millimeters, and so it's increasing. And very strong rainfall larger than 200 millimeters per day is increasing. Yeah. And also we have, I will not see here, and so from this kind of data is about the annual precipitation is about larger than 50 millimeters is increasing sharply, and also this is also increasing. That means the annual precipitation is kept almost the same, but actually for some special or very high rainfall, the occurrence, the frequency is increased. Okay, with so this have some result what? For example, the landslide. In Japan, in the world we have called everything. So the debris flow, rock avalanche, everything is a landslide. But Japan, they have special laws for different types of landslide. But totally, this is just the way say all those things. For debris flow, rock avalanche, everything, all called just they call it as a sediment disaster. Yeah, sedimentary disaster. So they call okay. So you can understand it's some landslide here. So anyway, so it's increasingly, almost with the year. So in recent several decades, so it's almost the 1.2 times than before. So anyway, so the landslide is increasing with time, and so with the climate change, so with the so you can say the number of the landslide increased. Another one is the annual precipitation, the shift from the the west part. Normally in the west part, we have lots of this kind of heavy rainfall. So the mountain here get used to this kind of heavy rainfall. But now this kind of heavy rainfall moved to the east part. So this mountain, this area doesn't have the experience to suffer from this kind of heavy rainfall. But so recently they get very serious problem in the landslide. So here we can show you some. Okay, so for example, in the west part, we have lots of the mountain. They got experience with how to say the heavy rainfall. So sometimes if you have very strong rainfall, so they get this kind of deep city landslide. Of course, sometimes they get result in the landslide dam, just as introduced by Professor Fan. And this is the west part. Yeah, we saw almost every year, not every year. You have quite frequent in Hiroshima city. We have this kind of river flow. Okay, so this is kind of in the west part, but now in the east part because the heavy rainfall moved east. So we have met this kind of landslide occurred on the gentle slope. So normally we don't have this kind of hazard area for gentle slope, but here we have lots of this kind of landslide in the east part on the gentle slope. Most of this area is covered by the teflon, the pyroclastic deposits. For example, the perhaps is the old deposit from the Fuji mountain from other volcano. So it's quite easy for this kind of gentle slope to suffer from this kind of landslide. So with the climate change. And this is the global data showing with climate change what's the possible the tendency of the landslide, the number. So you can basically on all of the world with increase of the temperature, and so the landslide number is increasing globally. Okay, so it's another natural hazard is floods. Okay, also the climate change doesn't have this kind of direct influence on the, for example, somehow trigger the floods, but actually it can affect the rainfall and the many things, so it results in the floods. So here's the, I take some photo of this from the States, the hurricane heavy in 2017. And this is the floods in Japan. Actually, this river is quite on the remote mountainous area, but the valley is quite narrow. Many people are living here in the city, but so sometimes they have this kind of central heavy rainfall result this kind of flood. This is the flood recently occurred in spring, perhaps you know that. Actually, is a result from this kind of centrifuge, the rainfall, and then got this kind of, so it's quite terrible. So with and the wildfire, and actually we have some colleagues in our institute, they are working on fire, but not on wildfire. But in Japan, it's not common for wildfire, but recently this kind of event occurred increasing, with time. And we can hear this kind of wildfire occurred in the west part of Japan, and especially in the summer or in the autumn. And this is the data from the States and from the world. And so normally they said with the increase of the climate change, so they didn't find this kind of increase in the number of the wildfire. So this is the statistical data, but the area is becoming, so it event becomes decreased, but the bond area is become serious. So once the event occurred, and perhaps a more wide area has could suffer from the wildfire, and also this is the damage increased with the climate change. And this is the season variation. So normally, so in the summer, it become more serious with the climate change. And this is the data from Canada. So I want to move it. And the draft. So with climate change, so some area, the globally, the rainfall or the temperature of the ocean can change. So it will affect the rainfall. And so globally, you can say the data, I got is from the Japanese colleagues. They said they got this kind of simulation. They said in some part it's become whiter, so perhaps can have some more rainfall, but most area they got this kind of become drier, And and also this is the degree for the dryer. So you can say almost area in the South American area and the Central America, and also, this is, I'm sorry, yeah, Africa, and then this is America and South America. So most of the area become drier. And so here is the example. For example, to show the draft in the Amazon area. So, for example, some areas is become more white. Okay, for example, Peru and this kind of area, but this part is a forest, area. So you can say it's become drier. So if you got drier, that means what? It means how to say this area can have more this kind of release of CO2, and then the release of CO2 can worsen this kind of climate change. So that means, okay, our globe will become worse and worse. Okay, let me. Yeah, so typhoon, and we do have some several colleagues, several research field, they're working on typhoon. And I didn't have the photo and the figure show the tenders, but actually this is how the calculated result from our director of our institute. And their conclusion is no obvious change in the number of typhoon or individual tropical cyclones. But the number of currents and the frequency of land fields in Japan will decrease due to the atmospheric stabilization. The risk of super typhoon will increase because of the surface temperature of the ocean is becoming higher, and the path is a good sense for Japan. Is the path of typhoon around Japan will shift eastward. Perhaps most of them they will go to the ocean, not the land. Yeah, and so another is a result from another colleague. He published this paper in. I'm sorry I didn't put the source here, and the paper was published in JRI. And their conclusion, they made this kind of global calculation about the wave height and the storm surges based on the data, and they get process the calculation, and they conclude. And so here's the result. I can't say that one. Yeah, in the Northeast Pacific, the frequency of the typhoon will decrease. The same conclusion as before. The frequency of annual occurrence of large-scale storm surges and the wave height will decrease. It's good for Japan. But the typhoon will become stronger. But extreme storm surges and the wave height has no clear change. So this is the climate change. Is significantly influencing the frequency and the severity of a natural disaster. The severity depends on different locations. Yeah. So what we should do based on this kind of problem? So we have to build a resilient society, and so at first we have to do this kind of monitoring. So we have to use the new technology for earlier detection, and also the engineering solution, and community resilience, and also innovation and using this adaptive strategies. And I think the last one could be the most important one. We should have this kind of collaborative efforts is building a resilient society, and the most important is reducing the emission of CO2. And I hope we have a peaceful world to reduce the CO2. Yeah, and thank you very much. That's all my introduction.
Thank you very much, Professor, for your talk on the relationship between the climate change, global warming, and their effect on the disasters. It was very interesting to see climate change effect, not directly on the wildfires, but their second effect, like affected areas. Thanks very much for your interesting talk. And now we will take a lunch break and we'll resume with presentations afterward. Please hold any questions for our panel session at the end, where we will have an in-depth discussion. Thank you. I think we are ready. Yeah, welcome back, everyone. We are glad to have you with us as we continue with the next setup of presentation. And let me allow to introduce impact licensing as a strategic approach to resilient innovation for regional emergency response. Professor Johan Moyersoen from Impact Licensing Initiative, Belgium. Please, the floor is yours.
Thank you. So, this morning, we heard really, I'm really pleased to hear all these telling presentations that already connects research and innovation to impact, which I really was really pleased to hear. My presentation today will be really about, how to accelerate the access of technologies when there is a regional crisis, but also how to make it more accessible for every crisis. Yeah? And thirdly, how to ensure that if you bring technologies available for crisis, that it's used in a way that is appropriate, and also that it's not disrupting also afterwards the economic usage of this economy, of this technology in a later stage. The dream or the ambition that I would like to put forward in this presentation is that there is a really high need to develop a sort of what I call an IP pool of impact licensed technologies, solutions that are really essential to resolve or to bring in place when a crisis emerges. When I'm talking about an IP pool, I want to make certain nuances. It's not only about the use, the rights of the use of the patents, of the IP rights, but it's really a broader view. So it's also to have access to the information, how it can be produced locally, how it can be deployed in a good manufacturing way, and also to have information how you can train people to use this technology. So it's a really broad view on what we mean with IP that we want to bring forward. It's really also a solution because you see that now a lot, if organizations and countries build up a sort of technology access strategy, it's always now a little bit siloed, although there are a lot of collaborations. This idea could really, that there is a pool of certain technologies that can be mobilized by all kinds of humanitarian organizations or initiatives. So yesterday I made a presentation. I don't know whether everybody was there, so I will explain a little bit what Impact Licensing Initiative is about. Yeah? And then I will go into the application, how we do think that impact licensing can be really a strategic tool to bring technologies to emergencies. So what we do, we are a non-profit organization that goes to companies and universities very practically, and we screen technology portfolios not from an economic valorization side, but really from an impact. So we look to research projects in universities, we look in companies to technologies, the products that they have, and we screen and see whether there are technologies that really can resolve important societal challenges in society. And if so, we take a sub-license on this technology for that usage. So normal licensing agreement is an agreement that you get the right to use it for a certain market or a certain sector or a certain geography for economic valorization. We take an impact license, and what we mean with an impact license is that we take a sub-license of the use of the technology to reach a certain impact. So we have, for example, a lot of technologies in our portfolio to increase the income of small farm holders in low and middle income countries. So these are long-term agreements with companies and universities that we can use certain technologies to help small farm holders to increase their income. If we cannot show that, then we are in an IP infringement. So if universities and companies give technologies through impact licensing, they know that it can only be used for a certain impact. Yeah? Once we have these impact licensing agreements, these are long-term agreements, so they are agreements of 20, 25, 30 years long. We raise capital and we develop this technology further to really applications that has a meaningful impact or a meaningful sense in that societal market. So we develop solutions that really help, for example, small farm holders to increase their income, but we develop also the business models to bring it to the market. So we screen technologies, we negotiate impact licensing agreements, and then we are acting as a sort of venture studio to bring these technologies to the market. So we adapt them to applications. Through that, we develop new IP, and we test it out in these markets, and we go for the first clients. That's what we do. So we really are a sort of technology transfer organization for societal impact. Yeah. Now, I started this initiative 5 years ago, and then there was COVID. And suddenly I couldn't go to the universities and companies to screen technologies. And so we started to think, yeah, how can we use impact licensing as a way to make access possible for critical technologies during crisis. So we wrote a paper on that, and that got the attention of the EU, and we were commissioned to develop this further because the EU really believed that impact licensing could be a strategic instrument to bring technologies for crises possible. And through that, we became a strategy in the EU IP roadmap to develop that further. So we developed this concept much further. We operationalize it in a sort of methodology. And now we are asked in the coming 3 years to really develop this portfolio, to pressure test that for different crises and to develop a first critical mass of technologies. So we are in a stage that we really want to pilot test these concepts with actors that are in the field, humanitarian actors, but also with universities and companies that has technologies available. Yeah? That's what we want to do. So why is it important to have the access of technologies during crisis? The presentation this morning has already told a lot, but one of the main elements is that a crisis often disrupts completely the supply chain. It can be really to physical destruction, but often also just to congestion of demand that makes that certain technologies, certain products are really difficult to bring to the region, and which create a lot of economic distress, but also societal distress, and therefore, a crisis can be seen as a sort of temporary, societal needs, societal challenge that has to be solved, and therefore impact licensing can be really a tool that the license really is activated when the crisis occurs and stops when the crisis is finished. Yeah? So that's what we really want to do, is really to think about technology access during crisis. And I would like to give certain examples that we saw during the COVID crisis, just in Europe. This is a case in Italy. In COVID times, the breathing machines for oxygen were really a critical technology, were really scarce. And in Italy, there was a really problem that there were spare parts that were broken. and that the supplier in England could not anymore supply. And there were these valves that were really an important critical subcomponent of these breeding machines, which brought them in a situation that a hospital had that their breeding machines were falling out and put people in danger. Based on that observation, a 3D company started to look into that and decided to reverse innovate this solution and to produce through 3D printing this valve, which are the prints that you see is from a 3D printer. But by doing so, he's taking, it's illegal. It's illegal because you're infringing the IP rights of this English company. And also it's illegal because there is, you're not following the regulation of health devices. And so this company, in collaboration with the hospital, made only 300 of these pieces, although there were much more needed, because they don't want to go in conflict in that. So they stopped to produce that, although this was really a critical technology. So there was the local production capacity to develop this critical technology, but the mechanism, the market mechanism, didn't allow to do so. A second, more positive observation is that you see also that several companies are starting to think about, how can we make alternative breeding machines? And there was a company that really looked in, because they didn't, due to the crisis, they could not do the normal economic activities. They put their personnel to think about new solutions. And they look in diving masks of the supermarket Decathlon. I don't know whether it exists in China, but Decathlon is a large chain of sports gear in Europe. And one of their popular products is a diving mask to dive in the sea and see fishes and so on. But this are very cheap diving masks. And so that company asked to Decathlon whether they could have the plans of the diving mask, and Decathlon say, you can use it for that impact purpose to make a breeding mask of it. And so they developed this breeding mask and produced more than 10,000 of these breeding masks during COVID crisis, which is a very cost-effective solution that really worked for people who had needed oxygen, but were not severe affected already. So this was a case of what we call frugal innovation, where, due to a crisis or and the innovation you want to do to repurpose certain technologies, you come with new solutions. That in itself can create new products that, when the crisis is finished, can have really a market, because these breeding masks are really a fraction of the price of these breeding machines that are normally available in the market. And that's what we do a lot, is that if we take impact licenses, then you create a certain innovation, and this innovation in itself can have a really good solution. And that's why companies and universities are willing to give impact licensing out their technology in condition that they get the return of the improvements for their normal economic market, for their core markets. So why would Decathlon give these masks and all this information about these plans and this IP away to a certain company? Is that, they want, because it's an open innovation strategy, they give it, the other company adapt it for a crisis usage, and Decathlon can get it back for normal economic use when the crisis is over. It's one of the mechanisms we see that allows or to convince companies to give their technology away for impact purposes. And it's also a mechanism that we can see be used for crises. So because a crisis is, of course, there is an important momentum where there is a lack of technology, but it's also an acceleration of innovation and testing of new solutions, where new products are coming out that also in a normal market situation can have a usage. So what is an impact licensing is really for us in a crisis is a time-bounded agreement that we can use the IP and all the knowledge that this company or this university has during crisis to make sure that this technology is accessible, can be, if needed, can be locally produced or assembled, and that once the crisis is finished, that there is a mechanism to go back to a business as normal situation. So that this company has not, or this university has not the risk that by giving their technology away for a certain crisis, that they give the technology away and that they're losing their assets. To do so, and to develop this, there is the need of clearinghouses. And the clearinghouses is what we do, but that can be a whole network of clearinghouses in Europe, in China, and so forth, that really negotiate these impact licensing agreements with universities and companies to establish this IP pool. Because as we saw also this morning, a lot of universities has developed solutions for crises. Through impact licensing, we can make it available for all kinds of crises, but we can also bring in, and that will the next presenter, Bianca Hanskens, explain, also bring in certain quality standards or guidelines that has to be followed for a good application, that it's really used for humanitarian aids. So these clearinghouses has really a role to broker these licensing, impact licensing agreements, but also to identify if it's about local production already in vulnerable crisis sensitive areas, actors that really can produce locally these technologies. An important aspect that we also promise to our technology holders is that by the usage of their technology during crisis, there is a lot of intelligence coming out of the usage of the performance of their technology. So it's not only the technology improvements that we were promising, but also the data. So that they get the technical data of the usage of their technology in this crisis back, so that they can further innovate on that. So that's really the role of a clearinghouse, is really to broker between the technology holder, that can be a university or a company, and the users of this technology in a crisis, and to broker, to ensure that if it's licensed out to a local manufacturer or to a humanitarian organization, that it's really used in the way that it is described in the impact licensing agreements and the standards. A third element that we really want to develop is a sort of quality label, because certainly in health, hospitals are, of course, in a normal situation, are procuring a lot of medical devices. And we do think by developing a quality label that a company or a university can highlight that their technology or their product is in an impact licensing agreement, that they ensure that if there is a crisis happening, that this technology will always be accessible as best as possible. And that this quality label could be a good way to promote impact licensing for crisis, certainly for critical sectors as health. That main hospitals are using technologies that are also through impact licensing possible to have access during a crisis. Why are we really developing these contractual agreements, and we do think that this platform is really important, is that there actually are not too many solutions out there to solve what we are talking about. Either we can build up, and you see that of course, a lot of organizations doing is to invest in critical technologies before the crisis. But for example, in Belgium, we had a critical stockage of masks in our storage, but we destroyed them 3 months before COVID crisis because they were lying there for 4 years. And so when we needed, there was no masks. And therefore, for example, with masks, it would be better to have a sort of impact licensing that you can, and to know where the local manufacturers that can be mobilized to produce these masks if it's needed. So it's one way is to reduce this proactive storage of critical technologies to a minimum level and to work with impact license for rapid production or rapid access of these products when necessary. A second element, but that's really very unpopular, is compulsory licensing. So where we, governments really forces companies and universities to give their IP away to have really full access. And that's really the last resort. We do think that can work because that's really something that companies and universities don't like, because it's not a tech transfer, it's a forced transfer, and where also no mechanism is foreseen when the crisis is over, how this has to be solved. But compulsory licensing comes always up, certainly during the COVID crisis on, for example, vaccines and so forth. And then you had all these, and that's what's really hopeful, it's these 3 pledges. There were also initiatives of the United Nations to make a big appeal to companies and universities to pledge their IP to resolve the crisis. And there were a lot of companies that came forward and said that they are open to do so, but there are no mechanisms in place to know how this transfer should work. There were also no long-term commitments, and there were also not economic arrangements how this is going to work. And so it was a little bit more a PR kind of element. But these 3 pledges, if you would structure them well in impact licensing, could work very well. So I'm referring to the Open COVID pledge. So impact licensing could be really a way to avoid, or to minimize this preemptive manufacturing, this idea of compulsory licensing, where the government is forcing companies to give their IP away, or just to rely on voluntary access of technologies where there is no long-term commitments. So how we see do it work is that we develop before that we develop this IP pool, impact IP pool, as a sort of long-term kind of technology pool, so that we really approach companies and universities that have critical technologies. And here around the table, there are a lot of research already going on that we have seen that could potentially be impact licensed, and really think about how we can support the development of this research and these technologies to really applicable technologies. So, and therefore, I was really pleased that, for example, last June in Turkey, there was when we presented this idea as well, there was the Eureka initiative to do a call of innovation for disasters. Eureka is a network of innovations agencies in Europe and beyond to collaborate on this, to develop solutions on that. And these kind of initiatives can really develop this sort of pool of technologies that really are brought together, have been tested, and through impact licensing could be brought available for any crisis. It can be also, and that's what I was demonstrating with this Decathlon mask, a way for companies for open innovation. By bringing this technology available, there is an innovation that can be done, and they can learn a lot about it. And the third element is, this smart procurement on this quality label is that, certainly in critical sectors like health, we could really develop a quality label where we really incentivize technology holders to bring their technologies also in impact licensing as a last resort, that if there is a crisis, that the technology can be, access can be continued. Yeah? What's the impact licensing about is that, that given following certain quality standards, how the technology is being used, that there is access to the use of the technology, that there is possibility where available for local production and innovation. What do we give back to the technology holder is the data, the technical data, to see whether their technology has really has worked and has certain outcomes in there, the improvements that has been developed on the technology, and a fair return on the usage of their technology during the crisis. But also a mechanism, as the crisis is finished, that it can go back to the normal market condition. So it's really, because there could be a lot of stockage. If you make thousands of breeding machines, you have a problem as a company that sells breeding machines after the crisis, because the market will be saturated, that there is a mechanism to take over these stocks and to ensure that after the crisis you're again in a new market condition, in a normal market condition. And so after the usage of the technology of the product in the market, it showcases what this technology can do, which allows also these companies to develop new markets or to develop it further in these markets. I will give you an example in a moment. So we thought a lot about what are the benefits for the IP owner, because it's really difficult to negotiate these agreements, so how can we ensure a fair return, economic return for them, but also to ensure that this impact license will not jeopardize their normal markets later on. So it's really a mechanism that also give guarantees to the technology holder that it's not losing its IP. There's also, we thought also a lot about the local manufacturer, what is going to get out of that, because that's also really important, because you, for example, with my my case of the masks, if you give the capability of a company to produce masks, after the crisis, they maybe are willing to further continue to do that. There is also a mechanism possible to do so, but then in a normal licensing arrangements. We looked also, of course, for the users, where really one element is really the guarantee access of the technology, and for society, which is really this proactive mechanism to ensure access of technologies. I will give certain examples, just not the traditional examples, but of technologies where we didn't thought about, but as a huge application in my feeling for crises, and that we have in our portfolio at the moment. And one technology is READS. It's a tool that has been developed for health education and treatment adherence, so that people take their medicines together in a way that it monitors the adherence in a way that you don't need phone access, but it can really monitor that people are taking their medicines, but also the health literacy is done in a way that it's accessible for people with low literacy of non-literacy. So the technology has been developed is actually a sort of bundle of IP. It comes from, a lot of the technology comes from the serious gaming industry. So these are designers that has developed a whole range of technologies to educate kids and adults through gaming. A second range of technology comes actually from legal organizations that made contracts, South African organizations that made contracts for people who are illiterate, and make methodology to develop through drawings, contracts accessible, and thirdly from global health experts. So we developed through these methodologies a solution. What we can say it's a read book. It's basically a solution, very cost effective, that has two elements. It's one, there's a hardware element that has different features. But three main features is that there is a medicine storage in there, that you can bring medicines in there, and if you take out your medicine, it keeps a timestamp, but also it reminds the person to take the medicine. The medicine can be put in own separate boxes, or can be used really also in their primary packaging, so you don't have to open it if necessary. Secondly, it has audio, so you can put in USB and you can change the language rapidly, and the audio reminds the person to take the medicine, but also tells the person also what's in the book. And thirdly, you can ask questions, and with buttons you can answer it. It has also a solar panel to power on, and you can have a booklet with these drawings, which allows to use it for health information and treatments during crisis. So you can really easily adapt this book locally to different languages for different treatments that are urgent, where you explain what person has to do. They can look on the drawings, they can listen to the story, and the medicines are in there. And it's a really cheap solution, and it's rapidly to make and to be adapted to different languages. So it's a tool that comes now from the serious game industry that can be applied for health access when primary healthcare is disrupted. A second solution is developed through a supermarket that has developed a whole series of cold chain technologies for their own storage solutions. But we have the license, impact license, to use it for access for health in the last mile. And we developed health carriers that can keep temperature-sensitive products at -18 up to 60 degrees, also hot, in a box. So you cool down these thermostatic batteries, these stainless steel plates, in a solar freezer. So we have containers that you can send and provide a whole cold chain infrastructure for a whole region. And you can charge these boxes for 1 day, 1 week, 2 weeks, or 3 weeks cold chain without access of energy. We developed IoT that really connects directly with the box, so it has not to go to the clouds, that monitors the cold chain, but also informs how long the cold chain will remain. So you can see how this box has still a cold chain of 2 or 3 weeks, so it can be stayed there. But so it can develop rapidly a cold chain and storage solution for a region that is in crisis. So these are these boxes that can have up to this one up to 16 days cold chain, but also is very modular in the solution. So if you need it only for 1 day, you need less batteries and you have more capacity. But so you can adapt it. And that's where, again, a solution. This has been developed to really for outreach campaigns for crises, but this solution is really also very useful in a normal market. And this company is also looking to use this to market this in other sectors. Yeah. Also in IoT, we have developed a whole kind of solutions that are adapted for crisis purposes, for asset management and so forth. We are also looking in construction and in wireless data where the normal infrastructure is not working, just to give you examples. So that brings me a little bit to the end, so that by developing this IP pool, we can really bring a lot of technologies to the market, but we can also incentivize companies and universities to develop solutions for that, for crises. Thank you very much.
Thank you very much, Johan, for your impressive talk on impact licensing, importance of it, how to reach accessible technologies during crisis for impact. Thank you very much. And let's move on to our final speaker, the critical role of NGOs in crisis response and the need of adapted technologies. Bianca Hanskens from Red Cross Belgium. Please, the floor is yours. Thank you.
So it's never easy to be the last presenter, especially not after all the presentations we had today, but I will do my best to keep up the energy a bit. So for today's presentations, I want to talk about NGOs or humanitarian organizations as a very diverse set of organizations that go from very small grassroots organizations to national, international, and even multilateral organizations. So they work on very different topics, but they are united by the commitment to bring relief to people who are affected by a disaster. So whenever a crisis occurs, whether it's due to floods, earthquakes, or conflicts, humanitarian organizations are often together with the civil the national civil protection authorities are often the first ones to respond. So they are there at the front line during the first phases of a crisis to provide immediate assistance such as medical aid, food, water distribution, and many other services. And here, the diversity of all those organizations and all the different expertise is crucial to be able to respond to the many different needs people have after an emergency. So while one organization focuses on providing, for example, medical care, Another one makes sure children are cared and protected, while another one builds shelter, for example. So when an emergency occurs, you often see this kind of pictures of humanitarian workers with the well-known jackets with different logos and colors, depending on the organization and the donors. And don't get me wrong, those people do a lot of important life-saving and often also dangerous work. But it's only a very small part of what we do. There is a lot of work being done behind the scenes. And that work behind the scenes is very important to keep up with humanitarian needs. So as you can see from the slide, the number of people in need of humanitarian assistance went up from 235 million in 2021 to 339,000 people in 2023. As a way of a comparison, this is more than the entire population of the US. It's not thousand, it's million. And as you can see by the purple line, the budget is decreasing while the number of people in need is increasing. And this situation, this trend will continue because there are three main sources or main causes of the increasing number of people in need for humanitarian aid. And the first one is armed conflicts. These are becoming more devastating with very serious consequences for civilians. 2023 saw the eruption of widespread conflict in Sudan, for example, and hostilities between Israel and Gaza. This caused a dramatic spike in civilian deaths and people in need for urgent humanitarian aid. Today, almost 1 out of every 5 children grows up or is fleeing from conflict. The second cause is climate change. 2023 was confirmed to be the hottest year so far. And this caused a lot of climate-related disasters, such as Tropical Cyclone Freddy in Southern Africa and Storm Daniel in Libya. Such disasters, they caused the destruction of many villages, but also they destroyed the livelihoods of many communities. And then the third cause are financial crises. These are a significant driver of humanitarian needs as well as they cause a lot of displacement. So these are the three main causes, not the only causes, and they can also overlap. So a community affected by conflict can also suffer from climate crisis or financial crisis, and this adds to the complexity of the crisis. So when we think of a humanitarian crisis or a humanitarian disaster, people often think about the acute crisis. So it's a sudden event. There is a lot of loss. Many people suffer injuries, they lose their life. There's a lot of damage to assets and properties, and it's often caused by natural disaster or sudden outbreak of violence. I think this morning it was also discussed. One of the most recent examples is the earthquake of Turkey, the earthquake in Turkey and Syria. So here in this kind of settings, speed is of essence. We need to react as soon as possible after such a disaster happens. The responses are multi-sectoral. This means that there are very different kinds of services needed, going from food, water, shelter. And after the initial response, the life-saving interventions, the response evolves towards recovery and rebuilding. But there's also a second kind of crisis, which is often forgotten. And those are the protracted humanitarian crises, mostly caused by events that emerge gradually over months or even years. And they are often the result of recurrent situations and events, and they can last for a long time, sometimes even decades. There are protected humanitarian crises that have been, that exist already for over 50 years. And it's often combined as well with weak governance or public administration, a challenging context to work in, and as I mentioned already, it's often forgotten and not visible in the media. People affected by this kind of crisis, they depend a lot on humanitarian aid for a longer period of time. Because it takes a long time, we focus not only on life-saving interventions, but also on building resilience. And we plan for a long-term response, often also combined with development projects. Again, these type of crises, they can overlap. So communities already affected by a protected humanitarian crisis can also suffer from acute crisis. That happened, for example, in Eastern DRC, which is a protected crisis, but with a sudden outbreak of violence, it becomes a sudden crisis as well. And that adds again to the complexity of the crisis. So on the one hand, we see that the need for humanitarian aid and the complexity of crisis is growing, while the funding is decreasing. And the combination of factors put the entire humanitarian system under considerable strain. So we as humanitarian organizations, we need to step up. We need to do better. We need to become more efficient and effective. And not only when a disaster occurs, but also before, to prepare people and mitigate impact, and afterwards when building back and prepare for the next crisis. And here is where technology is a very useful vehicle for change and improvement. To strengthen our effectiveness and to broaden our reach. It is important that the technologies that we use provide a real answer to the needs we identify on the field and are context sensitive. And that they provide a real solution to the different needs and differential needs as well of the affected population. And that they also take account of the local strengths and knowledge. So part of this technology is developed by the humanitarian organizations themselves in-house. Many organizations have their own R&D department, but the financial and the human resources that we have at our disposal are not enough to cover all the needs, because those needs are very broad, and they can go from more efficient fundraising and planning tools to green energy, communication, logistics. I mean, you name it, and most probably there will be a need for it as well. Luckily, there are many technologies that are already developed by private companies, by universities, that we can also use in crisis response. A very well-known, but also a very debated example is the use of drones. So the first drones were developed during the First World War by the military sector. And since then, drones have become some kind of a superpower vehicle that can operate in very complex environments, performing a wide range of tasks. Unfortunately, drones are not always used to benefit humankind and nature. I think we've all seen the images of drones being used to attack and destroy. But when drones are used in a good way, they can also support humanitarian operations. Mainly in two areas: to quickly map the scope of disasters and to overcome logistical obstacles when we are delivering aid, especially to communities that have become isolated due to damaged roads or floods, for example. So in this picture, you can see a drone that was adapted to quickly collect data necessary in order to provide adequate support. It's important to keep in mind that drones do not replace airplanes or do not replace human interaction. They do bring clear benefits and added value to the humanitarian operations as they are more efficient and can be more cost-effective. Because data collected by drones enable us to create detailed mappings with updated and localized information within just a few hours. Whether if we would send people to do the mapping, it could take days or weeks to get the same information and might not be that reliable. Current technology also allows us to even measure things like population density, access routes, and even risks or dangers that might endanger the lives of the humanitarian workers. So every piece of information can assist us to know what we are getting into, and therefore we can respond more quickly and more appropriately. It's a kind of technology and data that can save time, money, and even lives. But, however, collecting data also comes with certain risks. Collected data can also contain sensitive information, especially when it's accessed by a third party. Therefore, it's really important that we maintain full control over data and that the collected data is only used for humanitarian purposes. Secondly, the humanitarian organizations must ensure that data, the integrity of the data, the reputation of humanitarian organizations, they rely on the ability to maintain its trust with the local population. And if we cannot maintain the integrity and other people or other parties can access the information we have, they can endanger the population we work with. And then thirdly, regarding data availability, we have to ensure timely, safe, and reliable access to information and digital services. So, going back to technology in general, it's critical to assess how technical innovation intersects with values, norms, and beliefs of the communities we serve. We need to ensure that no additional harm, vulnerability, or dependencies are created by using the technology. As mentioned yesterday as well, during the opening ceremony, the communities have a lot of valuable knowledge. And any technology that is introduced needs to be contextualized to the local context and take account of the local knowledge and the strengths. And then, very importantly, technical innovation should always be in line with the humanitarian principles, which are embedded in the international humanitarian law. And these principles are humanity, impartiality, neutrality, and independence. This means that all technological innovations should have a real impact on the prevention and alleviation of human suffering, should be guided by real needs, and backed by data and evidence. They must be context appropriate and accepted by the affected communities and not be tied to any political or commercial agenda. And if this was not sufficient, at the Red Cross Red Crescent movement, we have 3 additional principles, which are voluntary service, unity, and universality. So we promote the free sharing of ideas, information, innovations. We promote a bottom-up approach with active participation of the affected communities in the adaptation process. And we are also looking to scale up the adapted technology to other places, other communities that might need it. And we engage diverse expertise across disciplines and industry, and we increase access to technological solutions worldwide. So going back to the example of the drones, we should always be careful when and how to use drones. In areas where drones are used to attack, we might cause additional trauma by using drones for humanitarian purpose. And we should also be aware of the cost efficiency, because it might be very useful to transport small amounts of medicine and blood, for example, but when we have to transport bigger quantities, it becomes very costly. And then, as I mentioned earlier, it's very important to ensure the safety of the data, so we can make sure people are safe and protected. So in summary, yes, technology is key and it's very necessary also in the humanitarian sector, but it's always vital to carefully assess and adapt any technology that we want to use. We want to experiment, we want to take risk, but we never want to cause any additional damage or create additional risk for the population. Therefore, we advocate for moving from the situation as it is now. So now technology use is often siloed by different organizations. Technologies are not reaching often their full potential, so they're still limited to be used in the primary target sector and not really for the humanitarian sector. And often there are no long-term contingency plans during crisis. So therefore, we're proposing to move towards an open platform with impact licensing technologies, as was already mentioned by Johan in his presentation as well. And that certified parties in every country can access that pool or that platform with technologies, because that way we can make sure that all technologies are in line with the humanitarian principles. But it's also important that we can monitor the implementation of the technologies and make sure they are actually implemented in line with humanitarian principles. Therefore, we would like to set up a data collaborative that monitors implementation, learns from it, adapts the technology to keep improving, and it should be like a continuous cycle of improvement and learning. Initially, it's the implementing organization that will be involved in the monitoring and the learning, but we're also looking at universities, for example, for academic research, leaders of local communities, focus groups, to ensure that the data we're getting is also very sensitive to the context. That way, we can ensure technologies are used correctly and in line with humanitarian, and only for humanitarian purposes, but we can also measure the effectiveness of the technology and any unintended consequence that we might need to rectify. So that was my presentation. Thank you.
Thank you, Bianca, for your presentation on NGO sites and explaining us why it's very important to reach critical technologies during crisis, and again, importance of impact licensing. Thank you once more. Thanks for our all presenters. Thanks very much for your talks. Now, the floor is actually our guests. If you have any question, please ask to our speakers. Yes, please.
Hello, my name is Juan Sobreira from Spain, ITG Technology Center. My question is for, I am sorry, Blanca or Bianca? Bianca. Does your organization have any pilot program to try to test innovative solutions? Why? Because, for instance, in my center, we have developed a system by combining robotics and drones to identify people in disasters, and also to support doctors trying to prioritize the illness, depending on how ill or how injured is a person, to prioritize the resources. Fortunately, we was funded by the European Commission, but now we have the typical pathway. If we want to go to the market, we need to accelerate and stop and wait for several years to go into the market. But in parallel, it might be interesting to test it in field, in this case. So I wonder, because we are new entrants in the domain of disasters, I wonder if you have any potential framework for civil servants and so on to try to test this sort of technologies, because it's a combination. We have developed technology or others, okay? I am the only one for sure. And it's a pity to not to try to help the ecosystems to go faster, not to the market in this case, to go faster, trying to help people when a disaster happens. Thank you very much.
Okay. So yeah, we do have a pilot program. We have several actually of technologies that we are currently piloting. Some of the technologies are already past the piloting phase and are now fully being scaled up. But in order to do it in a more structured way, and not only for us to use it as Belgian Red Cross, but also to allow access to other organizations, we're now looking at developing a more consistent framework together with Johan under the impact licensing, because that ensures the use of the technology for humanitarian purposes only. And yeah, will allow other organizations to make use of it.
Thank you. Another question? Maybe I can ask one to Johan. What are the main barriers to implement impact licensing, and how we can address it if there is an issue if there are some barriers?
Yeah, in my presentation, I would try to highlight. Yeah, we need to get the incentives right. That companies and universities brings really their really advanced technologies, the state of the art of technologies available for humanitarian crises, and that's really very important if you want to accelerate the tech transfer of technologies for humanitarian purposes to happen. One element is really to get the incentives right, that universities and companies are willing to sign the impact licensing agreement. And secondly is, of course, what I also highlight, is always a further innovation to do and a testing to do. What Bianca is doing in the Red Cross. All kind of organizations are doing that, but there's also a further innovation to do to develop applications that are really useful in that, and therefore we need further innovation funding. What, for example, Eureka has done with that call I gave in June as an example, is a good case where you incentivize companies and universities to do so, because otherwise we have technologies that has still a step to go to be really useful. So that's for me a second really important component. Yeah.
Thank you very much, Johan. Any other question, follow-up question? Do you have? Yes.
Hello, everyone. I'm Nanjing from G3. I have a question for Johan. I like the idea of impact license. But let's say you do impact license for the common good, right? Especially during the crisis period. So who get to decide that this is the crisis? And also, question 2, if you, let's say, if a company license their IP, let's say we find a scenario that we like this new product, who gets to own this product? Thank you.
That's a really good question. And to be honest, on the first question, that's something we really are struggling with. Who is going to decide what is a crisis? And also, yeah, when is the crisis finished? Because it's not on one day it's finished. It's really more, it's more long-term. There are different stages, and maybe there are also different impact licensing agreements. It can be in the same license, but for the different stages, that's how the technology can be used, because it makes no sense, for example, for the cold chain infrastructure, when the acute crisis is finished, that you take the cold chain away, because often the cold chain becomes really important just post-crisis, because it allows to develop a first economic development and so on. So it's good to have critical infrastructure in place. So in our view, there should be, it's international organizations that has to declare crises, but yeah, it doesn't exist yet, that instance that is doing that. On your second question on the improvements, that should be stipulated in the impact licensing agreements. So what's going to happen with the improvements, and what happens if the actors, the local user are investing in that, yeah, can they get the rights or not? They should know. But that's something in negotiation we have to arrange. Where we do see is that a sort of non-exclusive, exclusive use of the improvements for the national territory can be given. But we do think that the main advantage has to be for the key enable technology that is licensed out, that they are incentivized to give it for impact purposes. But that's something you can really structure in the licensing agreement, the second element. Your first question is a really an important and question that we really also want to bring on the agenda of EU and UN to yeah. If we want to develop this IP pool, we need also a sort of international framework that can declare these crises. Yeah. Yeah. But maybe you have a reaction.
I have the same. Following. Not a question, also the remark that so what kind of, the idea is very good, but practically, in terms of the application point, application means that, dissemination and getting the more audience to be attracted. So what type of visibility of this company? So, so what is the motivation? I know that, there's a kind of a need, but still, kind of at least a visibility or something. So how can you motivate the companies? Because end of the day, they are, so it should come from bottom up or top down in the company level. So, so if you want to extend this call to more, take the responsibility. I know that there are definitely some certain interest, but how we can extend to more audience?
Yeah, it's again a really good question. One element that we have already identified, because we are still in the ID stage to find the right incentives. But one is the idea of a quality label, because if you're procuring really, for example, these breathing machines, yeah, a hospital, if you a national hospital wants to know that if there is a crisis that they can have access to the parts. So if you have this quality label, that you can signal that if in the situation there is a crisis, that you can still continue the services, that this can be an advantage in procurement of your technology. That can be really a good element. And for example, in the EU, it's actually quite easy to implement, because you have this collective procurement mechanism in the healthcare sector that could say, look, if you have this quality label, you have a goodie points for in the assessment. That's one thing. Secondly is the innovation, where adapting your technology for crisis develops new applications for the markets, and for certain technologies it can be interesting. Certainly, if there is also funding available to do so, that's a second element. yeah, these are the elements where we are thinking, but do you have suggestions?
But I mean, since I have been listening, this is the third time. Each time I am learning more, and the idea is good, especially with involvement of the society. I mean, most of the IPs still includes a lot of know-how, so you cannot be produced without the help of the inventor. So. I mean, even you can say that, okay, you can use this license during this period of time, but it's not an easy to take. So, I mean, this is a kind of a development or implementing stage in the company. I mean, who needs that, I mean, still keeping the all regulations and, but still need the help of the inventor.
In impact, you have. We make it quite different. One is just a naked license. For example, the valve that I showed, it's actually, you put it in a scanner, you can make a 3D print out of it. So you need just the whites. That's really actually the most straightforward application. But as you say, there are a lot of more technologies which needs much more know-how, how to produce it and so forth. So what we do in impact license is also support. To have in the licensing agreements on tech support for the production. It's something we can provide. It ensures them as well that the products that are developed and locally are in their quality norms, but also that once the crisis is finished, that they really have also a good view how this production can be stopped, so that they have still control on certain critical production. But that's something that could be also in the impact licensing agreements, is what kind of support they want and what quality assurance that they want to have if it's local produced as well, because it works both ways. Yeah.
So, which means that it needs some kind of best or use cases. Give an example in near future.
Yeah. So, what we hope to do in the coming 3 years is really to do what we call pressure test, but it's really taking certain technologies and see how it can work. And there will be a range that is really straightforward to apply. There will be elements that maybe we will never be able to locally produce, but maybe regionally, which is already also a good case. And third, there will be certain technologies that are out of range of impact licensing as well. That's where, for example, if you take the vaccines and so on, that's very complex to produce anyhow. Yeah.
So maybe final, so I mean, in this respect, so maybe the UN Tech Bank for LDCs, because I think this is much more, because we need to create some best practices and should start something from the most simple, not the most difficult. And there are many crises, I mean, disasters in terms of the LDC region, and not in terms of really a disaster maybe for the developed country, but for them it's managing that is much more difficult. So maybe, I mean, the kind of use cases can be worked, because you need an interface. An interface should be more reliable. So UN Tech Bank may be a kind of a potential partner. Yeah.
Thank you. Yeah, something we really are active exploring is how we can work with the UN Tech Bank, but also from a larger point of view than crisis, really to bring technologies for impact to the low-income countries. The mechanism for regional crisis is very specific. It can be a subpart of these technologies that can be developed in the UN Tech Bank, but also in a larger collaboration with WAITRO. Yeah. Yeah.
Thank you. My name is Xuanmei. I'm from Southeast University, located in this beautiful city, Nanjing here. Okay. And yeah, I have a question to discuss maybe with Professor Wang. You mentioned about the issue about the global warming right? You mentioned that it's because of the CO2 increase in the past maybe 100 years or yeah, sometime. And because of this issue, the research topic about CO2 capture, CO2 use, CO2 storage have been very, very hot. Not only, I think in many countries, also now in China now. So my question is, the first question is, do you think all this, research, all this, even now in China, the industry very, enthusiastic about the use of CO2 in their manufacturing line, okay? So the question is, do you think all these methods can really, have some effect in controlling the CO2 emission? This is the first question. The second question is about, how about the Japanese government? Do the Japanese government, they have any special policy about the use of or treatment or capturing of CO2? Okay, thank you.
Thank you very much. Actually, I'm not working on this kind of policy. It's quite a difficult question for me. I think, yeah, it is, of course, yeah, many people there, some people there not believing that the CO2 is the direct reason, But from the scientific point of view, several years ago, last year, we have a Nobel Prize. Yeah, he's Japanese, working in the States. Actually, he, based on his model, he calculated the temperature increasing resulting from the CO2 increase. Okay, so this is scientific evidence. So, of course, the Earth is sometimes you have this kind of return. Sometimes it can become warm, sometimes become cold. Okay, this is how it's the Earth. Our globe is also has its own circle. So, anyway, so now the directed evidence shows that it's result from CO2. But I think because I'm not staying in China, so I don't know the policy here. But I believe Chinese government put lots of effort in reducing the CO2. I have some friends working in the central government, and actually they work hard to fight against this one. I think Japan is also trying to do that one. Yeah, actually, because they have very good this kind of technology to reducing the CO2. But of course, at this moment, I think sometimes for example, perhaps they have their own target, but now the speed is a little bit slower than expected, because several years ago they had this kind of nuclear plant problem. So now they are trying to, sometimes they also reactivated this kind of fire, this kind of plant, okay, to make power. And so recently, they start the nuclear plant again. So they are trying to reduce the CO2. But I hope, but I think the most reason is not from our developing country. I think it already has made by the problem already has made by the developed country. That's just my personal thing. Yeah, if you agree with me, yeah, or you can also don't agree with me. So it's just my thought. Yeah.
Thank you. I have a question, Professor Fan. In your presentation, there is a case. You offer the necessary information to help the government to make a decision. Yes, that's very successful. But I wonder if nothing happened. So what about it? If the government evacuates the people, but nothing happened. So I want to know your opinion about such kind of information, the management of such kind of information. How to manage it effectively. Yeah, to make a decision about evacuate the people is not so easy. Yeah. Also, it's the price also very high. Thank you.
Okay, thank you, Professor Zhong, for the question. It's actually, in reality, I think it's really a question. It depends on the accuracy of the early warning system. For example, if we give false alarm, then if we early warn, for example, if a landslide is going to happen and the government evacuate people, if at the end nothing happened, definitely becoming a serious problem. But for our early warning system, our laboratory developed, actually the success rate is very high. So basically now, everything we early warned actually happened. We don't really have false alarms, no single event. So we are also quite proud of that. But I know after the Wenchuan earthquake, I showed one of the example in my presentation, this big Tangjiashan landslide dam bridge flooding. At that time, because downstream, like Mianyang, and there were also several other small towns located downstream, people were evacuated when our government is, Chinese government is built the spillway, because they are afraid that maybe those towns going to be partly flooded. So people were evacuated to a region, and without any shelters to stay. And it was very, very hot during that season. So people really get sick, exposed, really outside waiting for the, signals to move back to their own home. But at the end, nothing happened. So that's one of the example from the dam bridge flooding kind of prediction. But it's, sometimes it's difficult to really predict, especially this kind of cascading hazards. But for our early warning system, so far, everything we early warned actually happened. So that's not a case in our system. But the hazard chain is particularly challenging, because when you transfer from one type of hazard to another type of hazard, the uncertainty increase. And the dam bridge process, it depends on the composition, material, structure of the dam, and it's not possible to really getting accurate geotechnical data of those dams. So that's a challenging part for predicting the flooding risk to downstream. So that's an example. I know we took some actions, but nothing actually really affected those people being evacuated. Yeah, but of course, with the more data we know, I think our model will, the higher success rate will be achieved, hopefully in the future. Yeah, thank you.
So you are talking about co-seismic landslides, I guess. You have an early warning system for the co-seismic events, for all the landslides. So you said you have an accuracy, almost you have the early warning system for all events. This is a quite nice score, but we need to also install this kind of early warning system in our country, because we have also many landslides, and the area in the Black Sea coast are prone to many landslides. But I'm not sure whether we should, really inform the people before the landslides happen. Instead, we are just trying to evacuate the people from the earthquake, from the landslide area. For example, after the February 6th earthquakes, we have searched at least 3,500 settlements, because we had almost 10,000 landslides triggered by these earthquakes on February 6th, and all mapped by our friends, by Tolga Görem and his team. And we realized that at least 250 people died because of this kind of secondary disasters, rock falls and landslides triggered by these February 6th earthquakes. How about the earthquake early warning systems? We are nowadays starting to discuss these earthquake early warning system in our country. And as long as I know, some countries in Mexico and China and using Japan as well, using this kind of early warning, earthquake early warning system, but this is a bit, triggering. Early warning, yeah. Prediction is quite different, yeah. Sometimes it is confused, yeah. It is confused by the people, by the local people, or even by the some experts as well, yeah.
Yeah, maybe I would like to make it more clear. Like the early warning system in my talk is for, let's see, gravitational-driven landslides. And debris flow is for rainfall-induced landslides. And what I present for earthquake co-seismic landslides, that's not an early warning system, but a prediction model, so which gave you the general spatial distribution probability of co-seismic landslides. For example, after the earthquake, we got the seismic data from China Earthquake Bureau or USGS. Sometimes we also use USGS PGA map. And then it being one kind of trigger factor into our model. And then the model can run itself based on the past data we have. The model we are already trained and all the data stored there. So the model can run very quickly. And the earthquake early warning is something also different because that in China, I think we also did quite a lot of research, not from our laboratory, but Sichuan province and my province, and also from China Earthquake Bureau, they have built this earthquake early warning. But that's actually not really predict earthquake beforehand, telling you, okay, where and when earthquake gonna happen. But that is for after the earthquake, because we install quite a lot of seismic stations, seismic network in the field. So that this data can capture, let's see, I think it's not a very complicated model because after the earthquake, we all know that P wave and S wave, they travel with different, velocity through the Earth. Yeah, and then it gives you the time difference from the epicenter to where you are located. And then once the first wave arrives, the seismic station can record. And then they just give you maybe 2 or 3 minutes early warning, depends on your location from the epicenter region. So that's actually already after the earthquake happened. And if you are exactly located in the epicenter region, there is no way to get this early warning signal. But even the time, the early warning time is very, very, small, but it's still helpful because you can shut down, for example, nuclear power stations, and the subway, can then stop some of the damage. I think that's the main purpose of this kind of early warning. Of course, people, if live a bit far from the epicenter region, and then they maybe have the time to, getting run out from the buildings. But again, mostly the most damaged region is near the epicenter region. So there is no way for people to take any actions, even they got the alarm signal. Yeah. So this is a prediction of earthquake and early warning earthquake is completely different thing. Prediction, I think, is not possible now.
Yes, I agree with that. Well, Japan may have more seconds because they have deep earthquakes, but we have shallow earthquakes in our countries, in China, in Turkey. So we have only 10 to, let's say, 30 seconds. For example, on the February 6th earthquakes, Antakya, the town in the southern part of the region, had the S wave in 31 seconds, 32 seconds, whereas Kahramanmaraş, which is very near to the epicentral area, took about 16 seconds.
May I say something? Yeah, actually, from the point of Japan, Japan, they are very, proud of making some this kind of good, alarming or the early warning. For example, for the earthquake. Not immediately after earthquake came, because they put a lot of this kind of seismometers. It's very densely located, so they can quickly identify the location, and then according to this kind of propagation, and then they got this kind of early warning. So it enables to escape, immediately. Yeah, of course, if you're very close to the epicenter, that's a problem. Yeah. But sometimes we have the problem, give a wrong this kind of learning, because sometimes they have this kind of, wrong working of the seismometers or some system. So sometimes no earthquake, but they get this kind of alarm. So sometimes if you work on you're in Tokyo or something else, so suddenly get this kind of alarm from your mobile phone. But it's okay, but for us, okay? Sometimes you just get this kind of noise, but anyway, they're trying to help you, okay? So concerning about the precision of this kind of prediction, I think even now, so actually in Japan, many people before, they trust the government, they trust our researchers so much, so deeply. But recently we're trying to them, don't trust us. If you trust us so much, so that means they lost this kind of conclusion, They lost this kind of ability to learn something by themselves. For example, from point of view of our landscape researchers. So, of course, if I go to the field, I did a very detailed research on that slope. Perhaps I can give you the correct answer, but I cannot do that one. So the only problem is you have to do that by yourself. Somehow I got this kind of knowledge, and then perhaps I will show you the approaches, and then you go to the field. Because you are living there, you are more familiar than me, around the US. So recently we have a new center. It's all my center, so called is risk cognition and relax. Okay, so that means, okay, you have to not recognize. Recognize means you were there and then you have to just know that, okay? But cognition means, okay, you have to learn this kind of risk to understand that by yourself, to increase this kind of your self-learning ability. Yeah, that's our, perhaps through this kind of effort, we can finally reduce or get this kind of mitigation for different disasters. So even in Japan, several months ago, we have the big earthquake just in the Nankai Trough, that area, because that area is now all the Japanese people, they are worrying about the occurrence of Nankai Trough earthquake because the return period is about 8 years. And then now it is past. So everybody just wait the coming of that big earthquake. But suddenly came about magnitude about 7 point something. So they thought this was the beginning of the big earthquake. And the government issued this kind of warning. So for example, all those hotels in many kind of Shinkansen, this kind of travel system, they stopped for some days. And many travelers, they canceled the resolution for the hotel, so they got a lot of confusion to local people. But the government said, we have to do that because actually everybody is expecting the occurrence network. But finally, the earthquake didn't come. So what we should do? So some people say perhaps we should stop this kind of early warning or something. But we said, we should do that, continue to do that, okay? So for example, we get this kind of issue 10 times, but 1 time we got, that will be okay. Yeah, so even if we made mistake 9 times, it was okay, You lost the property is okay, but lost your life, that means finished. So this kind of sense, actually, that's the method we are doing, trying to mitigate the disaster.
Okay, thank you. I did join a little bit late, but I'm from Zimbabwe. There was that incident in southeastern part of Zimbabwe where there were landslides that took lives and homesteads and everything. They were warned and they didn't take up. And then once the effect is gone, we see all these roads, there were big rocks on top of houses. Then after that, they built new locations away from there. You try to move people away from that site, they are not moving. So it's a situation again that we are saying, how best can we handle that? They are moving away from the danger zone, but they are not moving. And at the same time, it's really dangerous. You see these young boulders.
Thank you. Maybe one last question because we are out of time.
Thank you. Hello, everyone. So this is Wu Xuanmei from Nanjing Tech University. Because my research topic is seismic engineering and earthquake engineering, so I'm very curious about the 2023 Turkish earthquake. So I have 2 simple questions to Professor Hasan. So the first one is because the Turkish earthquake occurred last year, so caused such a large damages in Turkish. So I'm very curious about what kind of significant changes. For example, significant changes and the stricter requirements on the design specifications. And another is how about the because one of our goal is to do the disaster prevention and mitigation. So I'm also very curious about the education of the disaster prevention and mitigation in your country. For example, for the public, any public event or education for the children and for the public? Thank you.
Yeah, first of all, I just indicated in my talk as well, most of the buildings demolished after the earthquakes was constructed before 2000. This is one point. And we have a new building codes introduced in 2018 and was effect on the 1st of January 2019. So we have almost 5 years. And this kind of buildings constructed according to the latest Building Act was okay. They survived. And at least, let's say 0.5 of these buildings constructed in the area was okay. This is important. Even though we are nowadays trying to update our Building Act and try to not to have any buildings to be demolished after large earthquakes in the future. This is very important. So the second question is the education, of course. Whatever you do, you need to have an awareness of the community. If the community is not awareness of this kind of disasters, then you do nothing, whatever you do in the capacity building or increase the number of your monitoring stations and so on. Doesn't make any sense. So we need to increase the awareness of the community. This is very important. And we have an extensive educational program in Turkey. And nowadays we are trying to educate one person for disaster awareness education in each school. We have almost 70,000 schools throughout the country, and each school will have their own disaster awareness educator in each school, and they will start to teach the school boys and their families and so on. This is one hand, and on the other hand, we have a large number of AFAD volunteers. AFAD volunteers is about now 1.5 million. That was about 600,000 before the February 6th earthquakes, but the number has now increased up to 1.5 million. And of these, about 62,000 are support AFAD volunteer. That means we use these volunteers in case of any emergencies and send directly them to the field. This is important. And nowadays we are now using their experiences in the awareness education of the communities in the region. And another important project nowadays we introduce in our country is the increasing the awareness of the flooding, especially in the Black Sea coast in the northern part of the country, where we have lots of flooding in the last 2 or 3 years. But nowadays we purchased 100 excavators and gave these excavators to the state water authority and said, okay, you're gonna use all these excavators for the stream cleanings. And nowadays, along the Black Sea coast in 14 different provinces, they do this kind of jobs. In the meantime, AFAD volunteers go to the settlements, the villages, the districts, or the any kind of settlements. They do this kind of education for the public people. Okay, thank you.
Thank you very much. Yeah, we are end of our session. Many thanks for our esteemed speakers, panelists, talks, their insight into this important topic. Thanks very much for the participants. Also, many thanks to the organizer, WAITRO, and the G3 and NICE. Thank you, and we are looking forward to seeing you in another session regarding disaster resilience. Thank you.